All right, I think we're live here. So welcome everybody to the AP Calculus ABNBC 2023 review. I'm going to monitor the chat here just to make sure that I could actually, hear what people are saying here. So if, I'm going to wait a few more minutes here to get this practice test rolling. But what I'm going to do is I'm going to check the chat every so often to answer specific questions. And I'll kind of go off course, like what I had planned here. But yes, thank you all for joining in here. It's very exciting to be doing this. Oh, I'm praying for a parametric FRQ instead of polar. So at Voy 1, I know parametric is definitely easier. But the prediction I made a prediction that I think this year it's going to be polar because the last 2 years were parametric. But I, could be wrong here. But if we remember 2022, I'm just going to click on that real quick and double check. But yeah, 2022 was a parametric question. And 2021, I believe, was also a parametric. So I would imagine, look, if they go 3 years in a row, then 2024 is definitely getting parametric. But yeah. What's the most specific thing to focus on last minute to score higher? So that's a good question. I would say the most important thing to worry about for this test would be the big stuff, big theorems. So you want to go back through units 1 through 10, the curriculum guide. If you look at the, let me see here if I could just turn my display capture off for a minute. So I will start the practice questions at a little bit before 8, but let me just see here. I'll turn off my display for a minute, and I'm going to pull up something. Let me see. Finder. I might have this on my desktop just on the ready. So, but it's nice to see everybody, and, good luck. I could do some parts of FRQs if we'd like. I picked out a 1988 practice test. It's multiple choice, and it's no calculator. I figure I'd stick to some no calculator stuff. But once again, I'm going to kind of let the chat dictate where people want this review to go. 2 series and sequences free responses this year. I don't imagine that's possible. What could happen, though, at that question, so at Sabi, would be that question 5, the differential equation question, could have elements of convergence test in there. That's the most I've seen them do. Is, ask you to do like the integral test or something. So hello at Max, hello at Dory, hello at Tommy. Nice to see everybody joining in here. All right, let me just see. Let me look at my old lessons. I believe the curriculum folder. So this is a good question, like what to do last minute. Well, look, I would say just at this point, just go like brute force through practice questions. But one thing here that probably doesn't get enough is, and let me just resize this so that it's like a seamless, all right, transition here. Okay. So if I put my display back on, so if it's last minute, like, oh no, what do I do? Remember, I wouldn't stress over the small stuff. That's probably the biggest piece of advice I could give for the last minute studiers. So at Jack, the curriculum hasn't changed. Like, first derivative test in 1988 is still the first derivative test in 2023. I will skip over the parts of the practice test that I put together that I don't think are relevant anymore. Like there's a question maybe on Simpson's rule, which they no longer teach, or shell method. I'm up to date on the current curriculum, so I will only go through stuff that's actually relevant. But at the question on what should we be studying last minute is, if we look at this stuff here, I would say something like continuity at a point. That's a big topic. Okay, so if we look here at this PDF file here, continuity at a point is like a massive topic. I would say, intermediate value theorem is likely to show up, especially on AB. In the free response, it's either going to be IVT or MVT if it does appear. Stuff like, evaluating limits from a graph is probably something you're going to need to know. Something small, like something not to stress over, is like, oh no, squeeze theorem. Please don't spend 3 hours tonight working on squeeze theorem questions, because at most it's going to be, 1 or 2 points on the whole test. So this is not something that's going to wreck your score. From Unit 2, I would say here, knowing like the concept of a derivative, that the derivative tells you the rate of change of the function at a specific point, differentiability and continuity, like knowing when a derivative doesn't exist. Yeah, obviously you know how to do the power rule. You're probably going to have to do that about 50 times. Product rule, quotient rule, like that's just technique. Like you want to know your technique. Like, units 2, and I'll scroll over here to 3. So this is just welcoming people, and before we actually get the ball rolling here, chain rule is massive. Chain rule is going to show up at least 5 to 10 times, so be good at chain rule. Implicit is just more technique. Like derivatives of inverse functions, if you forget this or you struggle with this, this is not something that's going to wreck your score. If you don't know the chain rule, that will destroy your score. Okay, so what to study last minute? You don't have to do the root test on the AP test. That's not something that's part of the curriculum, because I never see that pop up in Unit 10. It's just not in the list. The reference sheet that I gave my students does have root test, but I don't even teach it anymore because time is money, and I only want to spend time on the stuff that matters. So let's see, from Unit 4, I would say related rates is good, because if you could do related rates, you could do like a lot of derivatives. Those are like the hardest questions like you might run into for the Calc AB people. That's even BC, that's one of the harder questions depending on how bad they make it. Approximating values using local linearity. So that's like using a tangent line to approximate. And for BC people, this is like doing Euler's method, but with just one tangent line. So this is a pretty big topic. L'Hopital's rule is going to show up for sure. Mean value theorem, I would know. All right, now Unit 5, let me just point this out. Unit 5 is like a big part of the test. So Units 5 and 6, if you're going to review anything, like 5 and 6 are like absolutely massive units. Not saying that the other units are not important, but 5 and 6 are like the heart of the test. So for Calc AB people, really make sure you know Unit 5. Calc BC, you really want to know Unit 5 also. You want to know like what is a derivative actually useful for. It's going to tell you where a function is going up or down. It's going to tell you local extrema. It's going to tell you absolute extrema. So you want to be good at the first derivative test, the extreme value theorem. You want to know how to use the second derivative to find intervals of concavity, points of inflection. So this is all stuff that's useful. Optimization, don't go insane worrying about optimization. That is like arguably one of the hardest topics you're going to run into, but I can't imagine it being more than one question. So that's, once again, not something that is going to wreck your score. Like you could still get a 5 if you're not the best at optimization. But one of the practice questions I have later does have that. All right, Unit 6. If you can't do Unit 6, that is just like the test is going to go really bad. So make sure you know what an integral is, that it tells you the net change of the function, okay, the behavior of accumulation functions, what a definite integral means. And then, for BC people, this is where your new topics start to come in. All right. And then, it's kind of the same flow here for the rest. I would say Unit 8 is probably one of the toughest units for Calc AB, and for BC, that's like a tie between, 8, 9, and 10 is like kind of a tie. Maybe 10 is the hardest, like because it's the most abstract. But if you're good at Unit 10, then yay. Yeah. What would you need raw score to get a 5? That changes every year. All right, and then I am going to start answering like actual calc questions in a little bit. So what's it called? To get a 5, you want to say like a 75% is like pretty safe. 70% may pull it off, but a 75% like basically like starts to seal it. 80, like you definitely get the 5. So it depends on like how bad the test is. I'm going to be streaming like random practice questions. So like it's going to be all different units. So at Menicam, so yeah. Yeah, 9 might be the hardest. I think what makes 9 like pretty awful, I won't even say the parametric. I think parametric is fine. I think it's the polar stuff. With polar, the hard part is like, that's like the only part, like there's a lot of memes that pre-calculus is just a massive waste of time. But the only part of pre-calculus I would say that matters is trigonometry. And, polar is an extension of trigonometry. So you really need to have like a high level understanding of trigonometry to truly master polar. That's why I think it gets such a bad reputation. But otherwise, at the end of the day, if you don't fully get polar, but you know the basic formulas, like, 1/2 integral theta 1 theta 2 r squared, that'll get you through, like on a 9-point question, that'll get you to like a 3 or 4 out of 9. Just knowing basics. If you want to get like the 9 out of 9 on those questions, then you really got to know your stuff. Midpoint Riemann sum is possible. It's either going to be left, right, middle, or trapezoids. So it is entirely possible for that to show up. Unit circle. Okay, that's one of those things that, look, if you don't know what sine pi over 2 is off the top of your head, that's going to hurt you on like one multiple choice question or maybe two of them. That's not going to destroy your score. Like these are like, not knowing trig values is like a little thorn that's like annoying in your side. So I wouldn't spend 3 hours tonight like memorizing trig tables. But if you don't know the fundamental theorem of calculus, like that will wreck your score. So once again, I would just focus on the big stuff. Yeah, pre-calc is like mostly useless. They don't test Simpson's rule anymore. So that's gone. This file here, if you want to Google something, just Google, I'm going to write it in here, AP Calculus, AB or BC course description. And if you go on College Board's website, you just Google this. And if you do a word search of just do a word search of squeeze theorem. Like that'll get you to this page where I'm at. And that'll tell you everything that's on the test. So Lagrange error is definitely tricky. Lagrange error takes like a considerable amount of time to like really master. But once again, if you're not great at Lagrange, it's going to be either one multiple choice question or it's going to be one part of question 6. So that's one of those things that it's not the worst. And the way they make it in AP Calculus, Lagrange is, it's something that you could just use a graph to fully answer. But I could sprinkle that in. What do I think? I do think this year is going to be a polar question. The reason being is because 2022 and 2021 were parametric. So I'm sorry if anyone's banking on velocity. Now look, I really hope they put a parametric in the FRQ, but they put a parametric 2 years in a row, and it seems like it might be time for them to do a polar one. That's the only reason why I'm leaning more towards polar. I mean, if they do parametric, that means next year, like almost for sure, it's going to be polar. To get a 3 on the test, you need like a 50% or so. So try to get a 50 on the test. That'll get you there. So no polar. I know. No one wants polar. Everyone hates polar. So, wow, we got 112 people. Thank you all for signing in. I really do appreciate this. This is pretty awesome. So here we go. How are the FRQs structured for BC? Well, I mean, I would say here is just knowing, like, if we go at let me just punch in the website here. So yeah, it looks like people are just more like interested in like specific questions. So let me do this here. Get this out, and maybe I'll put this up here. And let me see, how does that look in the... Yeah, I got 2 monitors. Last year, I only started streaming towards the end of the year. This is like kind of like a new... but like, let's say I look at, an actual test here. So I'm not going to necessarily go through this question, but how they structure it. Rate in, rate out is like almost guaranteed to be on the test. If it's not rate in, rate out, it's just going to be a rate in. So they'll almost always ask you to integrate one of the rates to find the total number of something. Then they might ask you like, find the average value. So you got to know like your 1 over b minus a formula, or you have to know how to find average rate of change. And they ask you, this is an application, this is unit 5. So unit 5, once again, is massive. So they ask you like an increasing or decreasing question. You have to take the derivative, you have to plug in, and you have to analyze. Like, my derivative was positive, so I'm increasing here. My derivative was negative, so I'm decreasing here. And like, that's your reason. If your derivative is positive, you're going up. Derivative negative, you're going down. But then you could see question 2 is either parametric or polar. And I scrolled way too fast. Let's just see here. So last year it was parametric. Now, these questions I think are the easiest. When my students came back, remember, you're never supposed to talk about the test, but they said like, hey, without saying anything specific, they said question 2 they thought was like really easy for them because it's just all formulas and you get a calculator. So remember, questions 1 and 2 structurally is not hard math, but it's hard concepts. Like, you actually have to know what everything means. You have to know what a derivative is. You have to know what an integral is. You have to know that the integral of the rate tells you the net change of the function. And that concept appears like more than once, like in like questions 1 and 2. So really know your concepts, because by the time you get to the last 4 questions, like that's when you actually have to know how to do math. A graph of f prime question or an area function of some sort is like almost guaranteed 100% to be on the test. So something like this, I would definitely want to make sure we know. And after this, let's see. Oh, a table of values questions is always nice because then they get to ask you a Riemann sum. And then they ask you either intermediate value theorem or mean value theorem. So make sure you know the difference between IVT and MVT. And question 5, they were just feeling funny that year. So they did a unit 8 style question and they mixed it with improper integrals because they had you revolve an infinite region unbounded over the x-axis. So I thought that was like a pretty, I mean, if you know your stuff, like this question's not horrible, but it was definitely tricky, especially considering like you only get 15 minutes per question. And then question 6. Oh, all right, structurally. So once again, this was a good question. Like, how do they actually structure the exam? This is 2022, the stuff I have up here. But how they actually structure the exam, the type of question you're going to get for question 6 is either going to be that they're going to give you a power series and have you answer questions on that power series. Or what they might do, so let me get rid of this. The other option as to what they could possibly do here is they might, and let me just get this set up here. I think this year, if it wasn't, it wasn't even this year. It would have been 2019 then. So 2019 is a different type of question 6. So there's really 2 types of question 6s for you to mentally prepare for. All right, so here it is. All right, so let me just drag this one over. And then I'm going to like just start like, going over stuff so that it's not just me talking about like what the test is like. So the other type of question 6 is they have you build a Taylor polynomial and all they do is give you information about the derivatives. So in one type of question 6, they're going to give you the power series, and a different type of question 6, they're going to have you build a power series. Or in this case, they're going to have you build a third-degree Taylor polynomial. And then they ask you follow-up questions based on that. All right, so that's just something to be mindful of. All right, so I will, I will, monitor the chat as we go. I'll just start going through some questions here. The first 2 questions I actually made space for because, there's not like a ton of space like the way this PDF was designed. But let's say something like this. Pretend this was like a no calculator question. If we had a no calculator question like this, the area of the region enclosed in the first quadrant by this graph and the x-axis. So for something like this, what you'd have to be able to do is I look at this and I have to be able to get a quick sketch. The roots would be x equals 0 and x equals 1. But this is a quadratic, and I'm looking at this and saying, oh, that's a sad parabola. It's like upside down. So if I get a little sketch here, I'm going a root at 0 and a root at 1. And I'm drawing this upside down like this. Okay, and we want to find the area enclosed, which is this space here. So for something like this, I would just set up here the integral from 0 to 1, and we would have x minus x squared dx like this. Now, one thing to be mindful of here is that your notation could be terrible in the multiple choice. So for something like this, I would just start anti-deriving using the fundamental theorem of calculus. So we have 1/2 x squared minus 1/3 x to the third, and we're evaluating this from 0 to 1. So then here, if I plug in, we're going to have 1/2, and we're subtracting 1/3 here. So you see I'm plugging in 1, I get 1/2 times 1 minus 1/3 times 1, and then I'm subtracting, I plug in 0, that's just going to 0 out. So then you have to know fractions. If this is FRQ, like the end of the FRQ, you could just leave this. Like I always joke with my students, like, oh yeah, just leave it, like whatever, let them add it and subtract. But for multiple choice, obviously, we have to work this out, and this would simplify to 1/6, which would be choice A. All right, obviously, if this was a calculator section, calculator like this is 1,000 times easier because like you don't actually have to know how to do like, any of that stuff by hand. So in a situation like this, let me just make sure this is lined up nice. Yeah, so I'm doing my best to juggle everything. I would just press math 9. I would go from 0 to 1. Okay, and if we just type in, what was it? It was x minus x squared. So x minus x squared. And then we just tack on the dx at the end. All right, and you see, you press math, enter, and you get 1/6. All right, even if you graph this, like if you want to see x minus x squared, you can see here that, and when something like this happens, like, oh no, I didn't bring my binoculars, I can't see that. A little trick, you could press zoom number 1, zoom box. And this is like cropping a photo. So I go over, I hit enter, I drag it down, and I drag it over. And I crop the photo in such a way that I only want the section of the graph that matters. And you see I get a much nicer picture. I'm like, oh, that's going from 0 to 1. So I can just press second trace number 7, and I go from 0 to 1. Okay, and it's like, oh yay, 1/6. All right, so just some more like, you know, little calculator tricks in case you don't know those. Something like question 2, and I'm just monitoring the chat here. Oh no, trig sub, you don't have to know that. They took that out of the curriculum because it used to make people too depressed. So they started to take it easy on all of you. My generation though, I didn't take AP calculus though. I was not an overachiever. I didn't take really any AP classes. I got motivated when I was like 20, but I'll tell my life story like on a different day because I think people just want to get this review going. So here, u equals x squared plus 2. So for the second question here, I would do u substitution. And I have du is equal to 2x dx. Now, there's different schools of thought, but one thing I like to do is, like I know when I make the u substitution that at some point I'm going to have u squared. And notice that takes care of this piece. But the x dx, I could build x dx by multiplying both sides by a half. So if I multiply this by a half, this whole thing, I get 1/2 du is equal to x dx. And you see that solves for the leftovers. So I'd have 1/2 du like this. Now, if you want to leave the limits in terms of 0 and 1, you can. But this is a useful skill to know, is that we could find new limits. So our new limits are going to be in terms of u. If I plug in the old limit, x equals 1, into my definition of u here, I would have 1 squared plus 2, which is equal to 3. Okay, so I'm just going to go about this once again by finding new limits. And then I'm going to plug in my limit of 0 into my definition of u. And I'm going to have 0 squared plus 2 is this. The only reason why I show this method is sometimes there's questions where they kind of force you to find new limits in terms of u. So now here, this would just be 1/2 times anti-derive. You're going to get 1/3 u to the third. And you're going from 2 to 3. And the benefit of doing it this way, you don't have to replace u with x squared plus 2. You could just continue with these limits. So this is going to be 1/6, and you're going to have 3 to the third minus 2 to the third, which is going to give you, let's see, 1/6 times 27 minus 8, and that works out to 19 over 6. Now let's just double check. Choice D. Cool. All right. So let's see here. Moving on to the third question. Let's see. We have f of x equals natural log of square root x. I put this one, like I said, on a fresh page so that we have space. Do I think the... let me answer some of these questions. So, good luck tomorrow, everyone. Yeah, so I'm glad, like I said, we have so many. Wow, 190 people. This is pretty exciting. So, polar... Who's ready for polar? Oh, yeah, no, I know. Look, I really hope for everybody. Like, but the thing is, how do I say it best? You want to be ready for anything, but there's a... You know, there is a chance that it could be polar tomorrow. You know, you always got to be prepared for the worst. Is one thing I'll float out there. So that's just like how you should prepare for any AP test. I mean, I know it's kind of last minute, so we'll just talk math here, but yeah, for like future exams in college, just always prepare for the worst. You know, expect the worst on the exam, and you know, unless the professor tells you like, hey, the test is on this. If they're like not very transparent, then you know, prepare for the worst. And the worst that happens is you don't do well. You'll still be you, so don't panic. All right, let's see. So find the second derivative. Oh, this is a nice little trick. So f of x, let me come back here. So f of, let's just fix this. This is like a little out of whack. Here we go. F of x equals natural log. I'm going to call this x to the half because I could rewrite this as 1/2 ln x. Now, the reason why I want to rewrite this is because taking the derivative, I don't have to do chain rule now. So f prime of x would just be 1/2 times 1 over x. All right, so that would be 1 over 2x, which is not an answer choice. That should be an answer choice, just in case someone gets sloppy and just finds the first derivative. So here, there's a few ways you could go forward with this, but honestly, I've taken the derivative of 1 over x so many times that when I find the second derivative, I'm just going, oh, 1/2 times negative 1 over x squared. And if I work this out, this is like negative 1 over 2x squared. Okay, and that works out, 3 works out to choice B. Now, if that didn't make sense, then look, what you got to do, you just rewrite f prime. This is 1/2 times x to the negative 1. And when you do the second derivative, just use the power rule. So the negative 1 comes down to make negative half x, and you subtract 1 to the negative 2, and that's still going to work out to this. Okay, but 2 minutes per problem, you want to be able to derive things like pretty quickly. All right, I can review Lagrange error bound. I will add that to the queue for sure. I will find a question where I'll probably look for like a free response question, because once again, like when I was first learning Lagrange error bound, like when I started teaching Calc BC like 3 years ago, and I hadn't taken Calc 2 since like 2008-ish, like really long. So I had to learn it, but I learned it with like a college calculus textbook. But the way they teach in AP calculus is like they're definitely like fair in terms of they kind of like, they don't make it easy, so to speak, but they don't make you do as much gritty stuff, you know, like there's yeah, no, I'll throw in an FRQ if we'd like. I know we have a mix of A, B, and BC people, so. Oh, also, if you could help spread the word that I'm live streaming right now. I don't know if you have any classmates that you have their phone number, but, you know, spread the word. There's a live stream for tomorrow's test. Although I think the algorithm will do that for me because, I don't know, I'm getting a ton of traffic today. It's a pretty exciting day to be a math YouTuber. All right, so let's see. Something like this, I can't imagine them asking a question like this anymore. Because, look, this is from 1988. And in 1988, they didn't have, like, really any calculator questions. The calculators back then were, like, just trash. That's the year I was born, by the way. A little Snapple fact for everybody. But the derivative of uv over w, I'm just thinking, like, oh, quotient rule. So I'm doing here, like, you know, the low function. So I would have w times the derivative of the top is product rule. So it's like u prime v plus uv prime minus I have the top function times the derivative of the bottom function over the bottom function squared. Okay, and if we do this here, we just distribute that, and that's going to be u prime wv plus I have w times uv prime would be uw v prime in no particular order. Remember, multiplication is commutative, so like these three terms could like kind of flip around a bit over w squared. And if we look, just for the sake of time here, that's going to match this choice. So you have u prime, what's it called? I have a u prime and a wv. So that's like this term here matches this term. And then I've got uwv prime. That's this term matching this term. And then minus uvw prime. This matches this. So choice E is our answer. And we move on. Integral of inverse trig functions. Oh, like integration by parts. So at Iris, yeah. Is there a pattern for the free response over the years? Yeah, someone had asked something like this earlier, but if I talk real quick about, like, if you look, let me just send this in the chat. I would honestly, here, like, check that out. Okay. So that's BC, and then if you want the AB one, so let's throw this in the chat too, is if you look at the last few years, like I said, 100% on the test. All right, okay, 100% on the test. Like for FRQ is like a rate in, rate out. Okay, they almost always ask rate in, rate out. The only thing that might not be there is this, like the rate out, but they'll have like some sort of rate in question. So that's definitely there. Then you're gonna have for, you know, BC people, you're going to have like polar or parametric. Okay, that's definitely happening. And then you're going to have like a graph of f prime question. You're going to have a like Maclaurin Taylor question. The one that like is a coin toss is like if it's like unit 7 heavy, like a differential, or unit 8, which is, you know, like a what's called like a volume of revolution type thing. It's more likely this, but sometimes it's unit 8. Like last year it was unit 8. So it's debatable. I almost guarantee though, like it would never be like, I can't imagine it being polar and unit 8. I feel like that's too volume area heavy. So yeah, those are like guaranteed to be on there. So yeah. Are these for, yeah, this is for free response, like free response questions that will be on the test, like for sure. Like there's like question 6, like this is like guaranteed. This is usually like question 3 or question 4. Question 2 is a coin toss. It's this or this. Question 1 is usually some sort of like rate in, rate out type question. So yeah. Oh yeah, good luck to everybody here. And once again, consider spreading the word. And if you're not subscribed, subscription would be much appreciated. But once again, I don't, you know, I'm not gonna, I do have that going in the corner of the stream because there's a cool feature of Canva Pro. But yeah. All right, so I'm gonna continue to talk about this stuff. Did I just finish? Oh, good, I finished that annoying question. So here, a unit 1 question for people. For what values of x is the function f not continuous? So for this one here, what I'm thinking is this concept. Like the limit as x approaches c on the left of f has to be equal to the limit on the right. So for something like this, the points where things could go wrong would be at 0. So you see like x less than 0. So let's make a nice number line here. Like if I have 0, I have 1, I have 2, like this. And let me color code this a little. So this is like, let's say orange. Then I'll go pink. And I'll go, let's say like lime green here. And we'll go purple. Is that purple? I don't know. I'm bad at colors. All right. Well, yeah, purplish blue, whatever that is. All right. So here, when I'm checking the limits, remember this is free response, multiple choice, so notation doesn't matter. What I'm doing is like, 0, 1, and 2 are the points of interest, and which is in every answer choice here. So I would check what's the left side limit, and that would be when x is less than 0. So I would go, all right, sine of 0 equals 0. And I would also check the right side of 0, which would be the pink region here, between 0 and 1. So I would also plug in 0 to 0 squared. And you see how these match? That means our function has a limit at 0. And it's continuous at 0 because the function is also defined at 0. See that as an equal to? So 0 is fine. So that means like these choices are out. So just like that, we eliminate. Oh yeah, also there's only 4 answer choices now, but this is an old test. So if I check 1, I want to check at, x equals 1, I would investigate plugging in 1 to 1 squared. Or for x squared, I would get 1. And if I plug in 1 to this, 2 minus 1 is 1. So like, hey, they match. And the function is defined at 1. So 1 is all good. So it's out. So it's like automatically it's going to be 2 only. And if I really want to verify at x equals 2, I plug in to the left side of 2 is this lime green between 1 and 2. I would plug in here. I get 2 minus 2 is 0. So that's my left side limit. And then my right side limit, I would plug into x greater than equal to 2, which will give me -1. You see how they don't match here? Like these don't match. Like those are not equal. So that means our function, the limit doesn't exist at 2, so it's automatically not continuous. So that's why it'd be choice C. Cool. Finding bounds of polars, you want to set the equations equal to each other. So yeah, I guess I could break every now and then and like answer. Let me just add a page so I could answer. So if you had like, let's say r equals 2, I'm gonna have to make one up on the fly. Let me see, r equals 2 would look just a circle like this. And I don't know, let's say like my second equation was like r equals I'd have to think of one that works. How about 1 plus 2 sine theta? Something like this. All right, so 1 plus 2 sine theta. What I would do is if I want to know like where those two overlap, and why not use a calculator a little bit here to like bring this to life so I get a better picture, because if I try to draw this myself, it's going to look like trash. I could draw these freehand, but like I'm not going to teach like limacon curves, okay, because this is going to be, I want to say this might be is that a limacon inner loop? That might not have been the best one for me to choose, but whatever. We'll go with it. 2 and 1 plus 2 sine theta. So sometimes they're polite and they tell you where they overlap. And let me press zoom 6. Yeah, so limacon inner loop. So let's say they're like, I want you to find, let me zoom in. Actually, not zoom in, zoom box. Let's crop the photo. So the dreaded polar, oh no. If they said find the area, you know, that's like inside the limacon and outside the circle. Like let's say we wanted this area here. Let me screenshot that. All right, so boom. And you know, let's say they gave you a picture, but they didn't give you like a calculator. They're like, here's the picture. Like which of the following integrals, blah, blah, blah. And the integrals, like the limits aren't all the same. So they actually want you to find it by hand. All right, so whatever, I'll go through this. Like we're looking for like this area here. Okay, that's the area we want. Actually, why did that color work out the same? That was really annoying. All right, let's try this. How about this area in pink? So if you had to do this by hand, what you would do is you would set these two equations equal to each other because you want to know like when are they intersecting. So I would set 2 equal to 1 plus 2 sine theta. And I would subtract 1 on both sides. This is gone, and I have 1 equals 2 sine theta. And now I'm dividing both sides by 2. And that gives me sine theta equals a half. So this is where you got to know some trig. And you would say, all right, ASTC. I tell my students, all students take crack. All right, no, all students take calculus if you're easily offended. All right, but that means your theta is going to be in quadrants 1 and 2, which makes sense because these curves intersect in quadrants 1 and 2. So your reference angle here, theta, sine of pi over 6, yes, pi over 6 is going to give you, what's it called, 1/2. Sine pi over 3, where 60 degrees is radical 3 over 2. All right, me personally, I just see the triangles in my head. I see like, all right, 60 degrees, drop down the altitude, this is 30 degrees. I'm drawing an equilateral. And if this is 2, this is 1, and this would be radical 3. So sine of 30 is like 1 over 2. I just see that triangle in my head from the SAT, if you took the SAT. And then remember, we're in quadrants 1 and 2. So if I did pi minus pi over 6, I would be at 5 pi over 6. So like those are my limits of integration here. So I'd have something like, all right, from pi over 6 to 5 pi over 6, and I'd have 1/2. The outside function is this one, so the outside function squared. Let me just, whatever, I'll just write it. The outside function squared minus the inside function squared, and then d theta. Okay, here like this. And if I wanted to be sure, like, hey, did I do my trig correctly? I would just do second trace value, and I would just punch in pi over 6 and check it out. Like, yay, it lands on the intersection. All right, so that's how we know we're good. So, oh yeah, the formula you would want to know for polar, remember 1/2 theta 1 theta 2, and it's like r outside squared minus r inside squared, d theta. All right, that's a good formula to know. And the way you know you're using this formula is because you see how there's a, like this is the origin, like the space. Okay, like if I connect, like this is pi over 6 radians, and this is the angle 5 pi over 6 radians, that the space over here is not the area we want. So that's how I know I'm using the formula for this. Okay, the other formula, like the main formula, is just r squared from theta 1 to theta 2. But what's it called? There's a space here, so I would use the more complicated formula. All right, so what theorems should we have memorized? That's a good question. You want to have the big formulas memorized. So if you're Calc AB, don't worry about 9 and 10, obviously. Yeah, thank you in the chat. IVT, MVT, EVT. Those are massive. Also, I would add first derivative test. You want to be great at. You want to be great at the, like units 5 and 6 have probably the most important formulas. But I talked about this earlier, like if you kind of rewind back to the beginning. But I would say, you know, what is the limit? You should be able to tell, you know, someone what is the limit. You should know what it means to be continuous at a point. You should know the limit definition of continuity. You know, like for the free response, you would want to know like, all right, the limit as x approaches c of f of x equals f of c. Like this means, like if this is true, like if this, then f is continuous at x equals c. What I teach my students, I say stuff like, oh, the third grade is, I could draw it without lifting my pen. But if you write that in the FRQ, they're going to laugh at you. So don't do that. Without lifting my pen. Okay? Like if I just draw something like like that's continuous. That's third grade continuity. Okay? That's good for the multiple choice. Like third grade definition is good for the multiple choice. But for the free response, you got to know like the textbook definition. So yeah, a part of the AP test is knowing like theorems and formulas like just cold. But be mindful that just because like you need to know the formal definition for the free response doesn't mean that they can't include that in the multiple choice as one of the questions. So you want to be ready for just about everything. So squeeze theorem important? Not really. It's if you want squeeze theorem, I remember the year because I remember kids complaining about it. Calc AB 2019, free response question number 6. Like I think it was even part D. All right. I have good long-term memory with these. Rolle's theorem, Rolle's theorem is like, yeah, so Rolle's theorem is another one that I laugh at a little bit. Like it's a nice one, but it's like Windows 95 Rolle's theorem. And MVT is like the, I don't know, like the iPhone 50. Okay, like, yeah. Wow, look at this in the chat. People know their stuff so well. So cool. Let's continue on. Did I get through? Oh, how about this one? A nice implicit question. Are we okay with implicit? If people want me to skip implicit, I can. I could skip it. Or if we want to see it, I'll go through with it. Oh, the difference between MVT and IVT. So, oh, how to justify and explain on the free response. All right, you know what? Let me just find one that has, let me see. How about an IVT, MVT, FR? I could switch off to FRQs a little bit. And let's see what time. All right, 8:20. So let me see. I'll go to Calc AB because that tends to be more like IVT, MVT friendly. Like BC has it too, but you're more commonly going to run into. All right. So I'm not going to go through the whole question, but let me pull up, add a page. All right. So this one, they gave you like, all right, here's h of t. And I don't know what just happened here. All right. All right. This is like zoomed in quite a bit. Let me close this. Okay. So we got this table of values here. It's the height of a tree. And here, even like the first two parts of this. Because if that's like, oh, how do I use these theorems? How do I explain them? And how do I know the difference between IVT and MVT? So just looking at this, my first instinct here is, oh, this is the mean value theorem. Now, how am I able to answer this so fast? It's because they're telling us to explain why there must be. When you hear this language, the first thing going through your head should be like, oh, it's either IVT or MVT. But explain why at some point H prime has to be equal to 2. So for one, the reason why we know it's not going to be IVT, well, for one, you could even just look at this and say, oh, H of 3 is equal to 2. So how do we know there must be at least one time? Like, they wouldn't just give you a value like and say that's the question. That would be like the weirdest AP question ever made. if they just said like, hey, explain why there must be a time where h equals 2. And if you look at it, it's because like they wouldn't just hand you that. But when they mention a derivative like h prime and they give you a table for h, that's how you know it's MVT. If I change the question, how about this? Such that h of t equals 14. Now this is IVT. Because I could say like, oh, on my way from, if you think about this, from like 2, 1.5 up to, let's say, 10, way up here at 15, like there's no way for me to skip 14. Because on my way from here to here, there's no way I'm skipping 14. Like that's why this is IVT. If they said, is h going to reach 14? But they're not talking about h. They're talking about the derivative of h. So think of MVT is like IVT for derivatives. That's like one way to think of it. So how do we know this is the case? Well, here we just have to find a subspace where the slope is 2. Because like this year it was like kind of mean. People always just go with the endpoints. They're like, all right, find the slope. And they're like 15 minus 1.5 over 10 minus 2. And then they're like 13.5 over 8. And they're like, oh no, doesn't equal 2. And they're like, I hate math. So this year, like they actually had you go on a scavenger hunt to find the 2 points. But if you look a little bit carefully here, you'll see that the 2 points, I want to say this is a change of 4 and a change of 2. Like here they are. Okay, I would say like, and look, just you doing this on the side. I'm going to check the rubric in a minute. But just you doing this and saying like, okay, 6 minus 2 divided by 2. 4 divided by 2 is 2. Like finding an average rate of change between 2 points that's equal to 2 gets you partial credit. And let me just go scanning because this was 2018. Because scoring guidelines, let's just see. So here, this was question 4. Oh, yep, there it is. So really pay attention to this rubric. So for MVT, if all you know how to do is like hey, I'm just gonna find the slope. You finding the slope correctly gets you, once again, it gets you 1 point. All right, but to get full credit here, you're gonna make use of the fact they told you that the function h is twice differentiable. So that's why they write here. I'll make this a little bit more jumbo size. So I mean, like just because for me to just write a sentence that they already have written, it's like just kind of pointless. But since h is differentiable, it's continuous, and on the interval from 3 to 5. So by the mean value theorem, there's going to exist a value c between 3 and 5 such that h prime of c equals the average rate of change that we just found. Okay, so it's really just a matter of using the table like for your scavenger hunt to find 2 points that have a slope that's equal to the target slope. Like here, like this is what we're looking for. And yeah, so these questions here, like once again, how do I know the difference? If they give you a table for h, so this is my thought process. If they like given like h, and then like they write like such that, and then they say h prime equals, that's how I know it's MVT. But it's IVT when they say given h such that h equals something. Like if there's no change from the function to what you're looking for, it's IVT. All right, so that's the main difference between the two. Hope that cleared it up a little bit. Oh, EVT is like a little bit important at Gavin. EVT is likely to show up with the rate in, rate out question. All right, but they could also sprinkle it in throughout the multiple choice. So yeah. Oh, how do I know to use? So at John Y, you just have to be able to find like, you have to be able to subtract and divide like somewhat quickly in your head. Like why not use like 3 and 7? Well, if you did these, that would actually, oh yeah, that would just miss by a little bit. I was like, oh, would that work too? Because sometimes there's more than one solution that's acceptable. But you see here, like, oh, 11 minus 2 over 7 minus 3. Like I'm just doing this at hyperspeed in my head. And this is going to give me 9 over 4, which is not equal to 2. So that's why that one wouldn't work. Yeah. So let's see. And average rate, but given the rate. Yeah, I'm trying to do my best to follow what people are typing in the chat, but I'm going to continue on with like some more of these questions here. So it looks like I'm probably not going to get through all these multiple choice because I like that people are asking me, you know, specific questions so that it's like a more custom review because it's for everybody here. So, so this one here would be like, you know, Calc AB and Calc BC friendly. Just know, don't fall in the trap. Like if you're a BC student, it's very easy to get so obsessed with like units 9 and 10 that you aren't ready for the other stuff. So yeah, I wouldn't take any of this stuff for granted. So here we're taking the derivative with respect to x of this equation here. All right. Now, if you don't know me that well yet, why is there a bear directly over me is because this question here is got a very dangerous bear trap. All right. So you'll see what I mean by that. So for this part, the derivative of a y term, just know conceptually, like the concepts, if I want to take the derivative with respect to x of y squared, I'm using the chain rule and I'm saying d over dx is really d over dy times dy dx. All right, so I'm doing d over dy of y squared, and then I tack on dy dx, which the derivative here is going to be 2y and then dy dx. So that's why you get an extra term. So 2y dy dx. But now this part you want to be really, really careful. So this is where the bear trap is. We're doing minus, and now what I like to do for this is when I take the derivative of minus 2xy, what you could imagine here, like I've done so many of these that, yeah, I will just write like minus 2y minus 2x dy dx. So if you really know your stuff here, like you just go fast. So yeah, you'll just go like, pretend like 2x is the first part of your project. I'm sorry, minus 2x is the first part of your product and y is the second term. You'll just have minus 2 times y minus 2x dy dx. But the most common mistake with this is that students forget to distribute the negative through. So if I went on a side quest here, just so you could see what I mean. So side quest coming up is pretend you're doing like u and v for product rule. So like u is negative 2x and v is equal to y. So u prime would be negative 2, but v prime would be dy dx or y prime. So you see why when we do this, we do negative 2 times y is negative 2y, and then I got minus 2x dy dx is my second term. So just make sure you get that double negative when you have like a minus 2xy, because a lot of people step in that trap. All right, so here, what you could do is you could group these two together. And I would probably honestly just divide everything by 2 right away. So maybe I'll do that first. Like just, if it's multiple choice, I'm just like crossing these all out like this, you know, because notation doesn't matter. But if I want to be really formal, like I'm dividing everything by 2. Okay, and then this is gone, and this is gone, and this is gone. All right, and I show way less work when I'm doing this in my notes. But because I'm like doing this for educational purposes, I'm going to show more steps. If I skip every step, it's like not going to be so helpful for everybody. I would add the y to the other side. So I'll go plus y on both sides. And now factor out dy dx. And you're left with y minus x. So this is going to give you dy dx equals y over y minus x. Okay, so 6 should be choice C. All right, and I'm just going to keep my notes with me to make sure, because I have been going all day. Cool. All right, so that one worked out. 7. All right, for BC people. So this one I know right away is not non-existent. A little trick you should try at the test is that if you had this, I know that this diverges. So this is for BC people. For BC people, what you want to know is that this should remind you of, let's say I go like this, n equals 2 to infinity of 1 over n like this. Okay, and this is the harmonic series, which diverges. So you could think integral test here for something like this. But this one is like, should make you think of like 1 over n squared, which converges by the p-series test. So this I would go forward with. So this is integral 2 to infinity of x to the negative 2 dx. All right, now remember, say this to yourself a few times. Notation does not matter in the multiple choice. Okay, if this was free response, in the free response world, I would be writing, limit as b goes to infinity, integral 2 to b, x to the negative 2 dx. All right, but this is not the free response. This is multiple choice. So that means anything goes. Anti-derive, 2 to infinity. And now when I plug in, me personally, I like to leave the negative constant on the outside. And I just go like this. So we're going to have infinity to the minus 1, minus 2 to the minus 1. And this is going to give us minus 1 over infinity, minus 1 over 2. 1 over infinity goes to 0. Once again, this is only multiple choice notation. Okay, do not write do not write this in the free response. Okay, because your grade in the free response is 20% communication notation. All right, so just be careful of that. So here you'd have minus minus a half, which is positive a half. So this would be choice A. All right, so something to be mindful of. Manifest 5, I hope so. I'm really rooting for y'all. So let's see. Oh wow, 360 people. I'm so happy that, oh wow, 1795 total. This is like pretty awesome to have this many people here. So thank you all for being here. For real. It's like, I started YouTube 10 years ago. I had no idea what I was doing. I was still living at home. It was just me and a whiteboard and like a cheap camera that sounded like I was, I don't know, filming out of a baked potato. And like now I got this cool setup and I got all of you here. So thank you for making this happen. All right, let's see. Moving on. This is a weird question. A natural log of f prime of 2. So here, f prime is just, like, do not derive this. Like, do not, like, derive. Because someone might go like, oh, like 1 over f prime of 2 and blah, like, don't do that. That's, like, just, this is don't. But just, you're finding f prime and you're building this. F prime of 2 is equal to e squared. So natural log of f prime 2 is just natural log of e squared. And now properties of logs, this is 2 natural log e, and natural log of e is 1. So this is just 2, choice A. All right, so cool, got A, staying strong. All right, let's see. That was one of our other tangents. Okay, so let me zoom out a little bit. It's like a big question. All right, which of the following could be pairs of graphs that could represent a function and its derivative? Oh, these are cool questions. So here's f prime, f prime. These are the same. All right, these are the same, but they are exponential. All right, so what if this was f of x equals e to the x? This is the easiest derivative in the world. I could derive this all day long. And yeah, that could be e to the x. So 1 is a possibility. So not 2 only, not 3 only, and not this. All right, how about this one? That one, no. And the reason being behind this is if this is f, you see how f is decreasing. So f is decreasing. So this is that unit 5 stuff, is decreasing on like 0 to infinity, which would mean f prime should be less than 0 on 0 to infinity. But you see how like f prime, like let's say this is like 1, f prime is positive on 0, 1, which contradicts this. So no, that's out. And if we look at this one here, let's see. This one is looking good temporal. Let me just see this. So at this point here, yeah, it's going up. So we have a local max. And a local max first derivative test is when f prime goes from positive to negative. And you see f prime is going from positive to negative at that point. So yeah, that one's looking good. And this is extra level. F is concave down, which would mean that F prime is decreasing. And you see how F prime is just decreasing the whole way. So 9, I'm going to go with choice D. Let me just double check. And it is choice D. Cool. Yeah, that one, like, look, if they get you on like a magnifying glass detail, that would be kind of mean. Question 10 is nice. Question 10 is, all right, look, question 10, if you forget this formula, be honest if you forgot this. How many of you forgot this? I didn't forget this because I know like what it means. That's the key to remembering formulas, because that's a popular question I would get is, oh, I like this, choice D on lock. It for sure is choice D. If you know this formula, I don't recommend doing it this way, but you're like, f of x is equal to sine x. And this is the formula for the derivative of f. So f prime is cosine. So choice D. Okay, this works. But let's be real. Who's going to forget this formula the day of the test? It could happen. So when in doubt, L'Hopital. You could L'Hopital this. And you'd have the limit as h goes to 0 of cosine of x plus h, derivative of the inside is 1. But what you're going to have here is when you take the derivative, like you're treating sine x here as a constant because h is going to 0. So this piece actually wipes out over 1. This is like a little bit more abstract because we're deriving with respect to h. And in this situation here, if you plug in h equals 0, you're going to get cosine of x plus 0, which is still going to give you cosine x. All right. This is more challenging, maybe. It's like challenging like L'Hopital, but it's still L'Hopital. It's normal to be scared at poop. Also, nice name. Yeah, L'Hopital is like pretty nice. Question 11, they don't really ask normal line stuff anymore. Like normal just means perpendicular, but I mean, I could go forward with it if you want. Let's see. I'll add a page. So let's see here. And how long are we streaming for? Wow, we broke the 1 hour mark. And it's growing. Yeah, if people could, once again, if you could help spread the word. I should have advertised this better on, what was it? On Reddit or something. I got to get better at marketing. But it seems like YouTube is doing it for me. So thank you to anyone joining here. And yeah, 90 likes. Oh, look at that. Thanks for liking. How many points to get a 3? 54. Try to get a 50%. Maybe less. Not 100%. How much longer will I be going for? I would say till 8 a.m. No, I'm not going to go to 8 a.m. That's way too much. Probably I'll probably go like a little bit past the 2 hour mark. So yeah, because yeah, probably I'm gonna aim for at least 2 hours of review on here. Okay, 575. Yeah, for a 5. All right, so if we want to do this, let me pull up a. Oh, you know, I could pull up one that was released to the public, because then I'm not doing a bad thing. Because I have the ones that only teachers have, but there's no shot I am putting that stuff on here and losing my AP license. Released exam. All right, something released. All right, I'm not breaking any rules. I'm gonna be a nerd. Do it the right way. All right. Let's see. Yeah, because I just want to get like one of those things like, oh, how many points do you need to get a 5? So this is from 2012. And this is for BC. Oh, would you look at that? A 50% was actually a high 3. Look at that. So this is 2012. But this is not guaranteed. Okay. SE 68 to 108. And a 3 was a 42 to a 55. So yeah, if you just do the division, 42 out of 108 total. So here, oh, we're going to put math in there. Why not? So this is the percentage game that you got to play. All right, so like from here to here is the percent you want. So think about that. Yeah, the 4 that year was like a pretty slim window, just 11 points. Yeah, 4 is like a really awesome. A 4 is like a little tragic though, because like you were so close to the 5. Getting from a 4 to a 5 is like you definitely got to know more stuff. And if you all don't know the story, like why do they make the test so hard? When I say they make the test hard, is that if you get the 108, remember if you get a 108, like you're gonna be on the news. So if like that's your score, like 108, you are on the news. Okay, and they will build statues of you. There will be a statue of you in front of your school. So, Calc AB is like about the same breakdown. So, something to be mindful of. But yeah, so that's generally what you want to go for. All right, I guess I'm just gonna keep blasting through this practice test so that we cover stuff. Here's question 12. I'm skipping 11 because it's just like kind of like a bland question. So I'll stick to like the harder questions. And if people want me to go back and answer anything from 1988, I will. But this is a popular question. A particle is going on a straight line, constant acceleration, so a equals 3. And velocity is 10 meters per second at 2 seconds. So v of 2 is equal to 10. How far does the particle travel during the time interval when the velocity increases from 4 meters per second to, this is a nice one. So look, this is constant. Acceleration is constant, which means velocity is linear. Okay, so from here, we want to calculate how much distance was covered. Let's see, how far, so how far does the particle travel is distance. And think about this, at 2 seconds, the particle is going, like this is velocity over time, is at 10 meters per second. So it's velocity in meters per second, and time is in seconds. Well, think about this. If this is constant, then our function is going to be linear here. And we want to kind of find out, when were we going this fast? Well, if we have a slope of 3, you understand, like we go down 3, we're going to be at 7 and over 1 like this. So that would be a slope of 3, like up 3 over 1. And if I go down another 3, that's going to bring me to 4. So there's my linear function here. And for this one, I can just do the integral of velocity from time 0 to time 2. Now you might be saying like, oh, hey, like total distance, like yes, you could do absolute value, but this thing is already positive. So we don't have to worry about any funny business here. So because this is linear, I would just find the area like this, the area from 0 to 2. And this is a nice trapezoid. And the area of a trapezoid is 1/2 height, base 1 plus base 2. And this is going to give us 1/2 times 2 times, the bases are the parallel sides. This ruins everybody's day when they learn about trapezoids in calculus, because every trapezoid you saw in geometry look like this. And then you get to calculus and the parallel sides are vertical. So sorry about that, but that's what's happening. And we have 4 plus 10. And now just do the math. 1/2 times 2 is 1 and 4 plus 10 is 14. So it's this choice. All right. If you wanted to, you could write the equation of a line for this, but I don't recommend it. Like some people might go crazy and go, all right, velocity equals like 3t plus a constant. Like they anti-derive this and then they use the initial condition like, oh, v of 2 equals 3 times 2 is 6 plus c equals 10. So like the constant is equal to 4. So then they have like v of t is equal to 3t plus 4. And then they integrate 3t plus 4 dt from like 0 to 2. And then they might even go on a scavenger hunt to find out when is the, when is the velocity at 4 meters per second. But unnecessary. Bonus detail. If you took physics and you memorized your formulas from the reference sheet, remember this formula? Wait, hang on. Vf squared equals vi squared plus 2ad. That would be really cool if you remember this. Because this formula, you wouldn't even need to do any calculus. And then you would just say, let's see if this works. I hope it works. Because I used to teach physics for like 2 years. So I remember some of those formulas. So let's see. From 10 squared is 100. 16 plus 2 times 3 is 6. times the distance. So we subtract, that's going to give us 84 equals 6d. Divide by 6. Oh, let's hope. Well, math has to work no matter which way you do it. Like, oh, yay, still 14. Okay. So, oh, physics C mechanics. So at Sabi, is that formula still relevant in physics, like for AP? I didn't teach AP physics. I taught like standard physics, like non-calculus based, because there was like a science teacher shortage at my school. So they were like, hey, you teach calculus, you could probably do physics. I was like, all right. Like, it was fun though. I don't regret saying yes. It was an experience. Physics C next year, good luck. Good luck. All right. So moving on. So that was 12. Should I go into super speed? Oh, here we go. Unit 10. All right. Memorize. What do you have to know? Memorize. You have to know the Maclaurin for these four. Okay. For sine x, cosine x, e to the x, and 1 over 1 minus x. You have to know those four cold. All right. That will save you time. Because sine x, I know is this. Okay, that's my Maclaurin. Like this. And then when you want to find sine of 2x, you just have to know how to do composition of functions. Okay, so sine of 2x would be equal to, we would have 2x minus 2x to the third over 3 factorial plus 2x to the fifth over 5 factorial minus dot, dot, dot. So you're just replacing every x with a 2x. So this is just like more algebra skills. And just know, the AP test, like not being funny, is 80% algebra. Okay, like your algebra has to be pretty awesome. And maybe that's like a high one. How about this? AP test, like the no calc sections, you really need algebra to be successful. Okay, like if you can't algebra, like these questions are going to be awful. So 2 to the third is 8, x to the third over 3 times 2 times 1. Yeah, just know 3 factorial. That doesn't mean shout 3. Like, don't yell 3. You're going to go like this. All right, and that's over 6. Plus 2 to the 5th power is 32. X to the 5 over... oh, they don't even simplify here. What am I possessed here? What am I doing? Yeah, so how about this? Also, look at the answers before you waste time. I'm still learning that. Okay, but I'm also juggling like, 2 monitors and all this. So I don't know, maybe I deserve a little forgiveness. So this is where I could have stopped. I'll never get those seconds back. So let's see. Starts with 2x. So like gone, gone, gone. It still alternates. So I believe it's going to be 13 should be choice B. Yeah, 13 is B. Cool. So we're good. I didn't even go to the general term here because didn't need to. All right. Optimization. All right. So I love optimization. Remember, the theme for the AP test is know the big stuff really well. If you don't know optimization, like, yeah, maybe do 1 or 2 questions to like, if that's the only thing you don't know, then work on it. But if there's other stuff you don't know well, I would work on that first. Because optimization will not ruin your score. Okay, the last question on this practice test is an optimization question, a really mean one too. It's like the worst one. And every time I assign it to my students, I get like maybe 1 student that gets it right. Because it's like the first day they're learning optimization, but it's just pure, just absolute hell. Yeah. So let's see, moving on. So this one... Oh, okay. You got to know, for question 14, you got to know this formula, the derivative with respect to x, integral q of x to p of x, f of t dt, is you replace, like you plug in the upper limit for the variable. So I plug in p of x to the function, and I multiply by the derivative. And then I subtract, I plug in the lower limit, and multiply the derivative of the lower limit. So here, I'm just going like this. I'm going radical 1 plus, instead of t to the third, it's x squared to the third, but it's x squared, not x. So I have to multiply by the derivative of the top, which is going to give me 2x. And then I subtract. Look, I could plug in the bottom here, but the derivative of a constant is 0, so this just wipes out. So this is going to be 2x on the outside. Let me get rid of this. Don't need that space. 2x, and then we got 1 plus x squared to the third is x to the 6. So 2x radical 1 plus x to the 6. 14 is A. Alrighty. Oh, someone got... Oh, yeah, C is if you chain rule. Okay, LOL. Chain rule. Remember I said the chain rule is going to show up like 5-10 times. This is the chain rule. What you're thinking of is this is the polite case. Is this. Okay, this is the polite one. Okay, that's as nice as it gets. This is like the chain rule version. All right, so compared to the AP exam, I mean, this question is like this could be on the test. This is like I would call this like, you know, medium difficulty because it's got a lot of moving parts to it. This is not easy, this question, because of the choice C bear trap. So yeah, go over. Oh yeah, error bound for series. Yeah, I'll add that to the list for sure. Let me look. I have to look at actual free response questions. Let me pull up one. I think it was from 2012. Was it that far back? Because they don't ask Lagrange a lot. They usually ask alternating series error bound. When they ask Lagrange, it's like, what's it called? Lagrange is like 1 out of 4 times or 1 out of 5 times. It's like not popular. Yeah, so this is like, let me see. How far back do I have to go? Oh no. Is it 11? Oh, here it is, 2011. All right. So only because it was, you know, requested. Let me do this. I'll add a page. I'll do Lagrange question after this. So I'm just going to do part of the free response. I'm not going to do a whole free response question because that takes like insanely long. And since there's Calc A, B, and BC people, like I want to share the wealth. So, all right. So that's like the one I always think of. And I'll talk about the bear trap for Lagrange because there's traps for Lagrange. Lagrange bear traps. All right. So position is given by this. Acceleration vector. Oh, so here we got to just find 2 derivatives, don't we? All right. So this is position. So the velocity vector would be, we take the derivative of position, and that's going to be 2t, comma, take the derivative of this. Oh, there it is again. Chain rule. Know the chain rule. Okay, because if you just say like, oh, 1 over 2t plus 3, and you forget to multiply by the derivative of the bottom, I'm sorry, the derivative of 2t plus 3, that's going to be very tragic. Okay, don't let that be you. So now here, we have to take the derivative once more. So the acceleration vector, we're going to take the derivative of 2t, which is 2. And then for this part, you can just think of this as like, all right, what's the derivative of 2 times 2t plus 3 to the negative 1? And this will work out to, it'll be negative 2 when this comes down, 2t plus 3 to the negative 2. But then chain rule, derivative of the inside is 2. So that's going to give you negative 4 over 2t plus 3, and it's being squared. So 15 is choice E. Cool. All right, Lagrange error bound. Here we go. They're going to tell you to use Lagrange, like basically. I mean, here you can't really use alternating series error bound because you don't have... wait, give me a minute. Let me think. Because I got to like jump into this question. Oh, wait, am I really going to have to build this from scratch? Wait a minute. For F. Where's F? Oh, okay. So we have to do part B for this. So I'm just going to screenshot part B because like that's not the like focus of the question. Like I don't want to do like the entire FRQ from scratch. Because because that's just going to eat up like 20 minutes. But let's say you get, you get to this step here. And let me just see here. So we have, let me just pull up this part of the rubric. I have to like get into the mode of the question too, if I'm going to explain this well. So ultimately, for one, you have to know Lagrange error bound. The way I remember it, because it could be hard to remember, is think of, so let me fix this. This is what I think of. It's like, oh, f of c plus f prime c x minus c plus f double prime c x minus c squared over 2 factorial. And I'm going to continue it over here, like plus like the nth derivative at c, x minus c to the n over n factorial. And then here it is. Here it's coming up. If I were to keep going, and I should have dragged, let me drag this over. Oh, wow. I really just took everything with it. Oh, because this is, could I just move? Oh, yeah, I mean, whatever. I'll just move the whole thing. All right. So this plus, we have the m plus 1 at c, x minus c to the m plus 1 over m plus 1 factorial. Plus dot, dot, dot. Like theoretically, if I wanted to write infinite terms of like, Taylor series at x equals c, like this is the big formula. But we usually stop at the general term. But the error for Lagrange is we got absolute value m plus 1 derivative at z instead of c, x minus c to the m plus 1 over m plus 1 factorial. Okay. And actually, you know what? I don't even need, I lied. We don't even need the rubric for this. We don't need to continue from part B. This question actually could just answer straightforward. So this is the part I would say that's most confusing. So what you want to think about here is that, for one, you have the center of your series. Let me make that neater. So you have the center of your series, and then like whatever x is, z is like some value between. Like z could be anywhere. All right, so z could move. But z is the value that makes the derivative as large as possible. Okay, because once again, z is the value that makes the m plus 1 derivative as big as possible. So it really just depends on the question. And one thing to be mindful of, the bear trap here, is that people look at this and they're like, oh, my z value is like at the end, like I'm just going to go up to like 120. They just look for the biggest value. But you have to be careful. You got to think about what everything means. So here, what they told us, the word about tells you the center. Our center is at 0. Okay, and then this is the approximation using the degree 4 polynomial. So remember, Taylor polynomials just approximate. This is the actual. So this is the error. Okay, if you find the difference of the approximation and the actual, that's the error. And we need to use this formula to show that we're within 1 over 3,000. So we're centered at 0, but what is the x value that we're plugging into the function? We're plugging in 1/4. So this is the bear trap you want to avoid. If we're going from 0 to 1/4, that means we are on this space here. See, 1/4. We're only looking from here to here. So that's like saying here, like now we're between 0 and 1/4. So now where would our z value be? Our z value is going to be all the way at the end, because you see how the graph of the fifth derivative is going up from 0 to 1/4. So we would take this max value here. Now, I don't have a magnifying glass. I could say 35, but I can't say it confidently. So I'm going to be very generous here and say the max value is 40. So what I would have here is the error, I'm going to say is going to be less than here. We could say less than, or and look, if you want the actual formula, I could write the entire formula out for you, but what we normally say here is that the error is you could just say here is like, going to be less than or equal to, we have the max value of the n plus 1 derivative. Be mindful here that n is equal to 4. So you see, if we plug into this formula, we're going to have the max value of the fifth derivative at z times x is 1/4 minus the center. And now we have, if n is equal to 4, n plus 1 is going to go to the 5 over 5 factorial. However, the max value of the fifth derivative on the interval from 0 to 1/4, we're just going to set it to be 40. So this is going to be, we're going to have 40 times 1/4 to the fifth. All right, this is going to get to be a little annoying, these numbers. For this one, you could just trust that you did it right and, be happy with that. Otherwise, like if you want to do the math in your head, I just say like 4 times 4 is 16, times 4 is 64, and 64 times 4 is going to give me 256. And if I do 256 times another 4, that's going to be 1024. All right, so that's how that's working out. But it's a 1/4. So I would be, times, I'd be over this times, and I would have like 120 here like this. Now, if I had to simplify this, this simplifies to 1/3, 40 over 120. And then 1024 times 3 is 1 over 3072. And that is definitely within 1 over 3000. Okay, so there's our Lagrange error bound here, that we're taking the error and it is less than or equal to, and then we use the Lagrange formula. But once again, you want to make sure that these are important pieces. Fix your center and the x value that you plug in, and your z value is between those. The max value is going to be one of three things, and this is from the College Board people. So the max value, like this piece, is going to come from three things. They're either going to tell you, okay, like they might have said, like in a different situation, like the absolute value of the fifth derivative of x is like less than or equal to 7. And when they tell you it, then you just plug in 7. Like, yay, this is the easy. This is as easy as it gets. This is not an easy question, but it's as easy as it gets. Or they give you the graph, and that was this question. Okay, and then the third case that pops up is that it's like sine or cosine, and you just like make it equal to 1. Okay, so the graph one is like a little tricky, but when they tell you, that's as easy as it gets. All right, so that's Lagrange. Yeah, 2011, that's far back, but it's still relevant. Okay. Oh yeah, for part C, I would just once again punch in 2011 because I don't want to go through this entire question here because I want to keep it fair to the AB and the BC people. But for this one, if you want to know the sixth derivative here at 0, let me see if it's a quick explanation. All right, you know what? I'll compromise. What I'll do is I'll pull up the f of x and I'll show you the idea. So assuming you found f of x correctly, f of x was supposed to equal 1 plus x squared over 2 plus x to the 4 over 4 factorial. And then they give you, what's next? Minus 121 x to the 6 over 6 factorial. And then plus dot, dot, dot. And part C is like, what are they asking for? What's the, oh yeah, fine. They're like, the sixth derivative at 0 equals blank. So just think of the formula. Remember, it's the n derivative at c times x minus c to the n over n factorial. But here, we are dealing with a Maclaurin series. Okay, we're centered about 0. So what we should be thinking about is a simplified version. We're looking for this formula, the n derivative at 0 times x to the n over n factorial. Okay, so what that tells us, though, if you think about it here, if we're looking for the x to the 6th term, then I'm thinking, oh, n equals 6. Okay, so this is the general formula, like the general formula. And it helps you build every term. So the shortcut here, because please don't actually take 6 derivatives. That'll take you a while. Although that would still work, is what you're going to do is you're going to match it to this term. Okay, because if I have the 6th derivative at 0 times x to the 6 over 6 factorial, that has to be equal to my x to the 6 term, all of it. And now just algebra. Goodbye to this, goodbye to this. So that tells you the 6th derivative at 0 equals minus 121. All right, so those questions aren't bad, but assuming you built f of x correctly, it's not bad. That's like a nice little trick. All right. So how about integration by parts? Is that something we want to see? All right, let me just make sure I don't have too much open so this doesn't slow down. Checking out the chat. Yeah, I think there's a related rates question later on in this. Simpson's approximation is not on AB. Yeah, it's ancient. Just watch an episode of The Simpsons instead. All right, let's see. So this one, oh yeah, Liate helps. That's the order in which you should choose your U term. So this is algebraic, and that beats exponential. So I would say, oh, U equals x. dv is equal to e to the 2x. Let me actually put this on a fresh page because this is not going to, I'm not going to have a lot of space here. Do we want to see it by parts? If you want to see, I'm sorry, a partial fraction. If you want to see partial fraction, say so in the chat. Because every time I have to do partial fraction, it like takes a piece of my soul. They take way too long. But if like people really want to see it, then, you know, I will. But I prefer not to. Because how long are we? Oh, wow, we're an hour and a half in. All right. So here, u equals x. Let me make that neater. U equals x. dv is the rest. Now, if you don't remember the formula, it's product rule but backwards. So I would just integrate every piece like this. And the integral of uv prime is just uv equals the integral of, instead of u prime, I'm going to say v du. U prime and du are like interchangeable here. There's like just a quick proof. So I'm defining u dv, so that's this piece. So I could say the integral of u dv is equal to uv minus the integral of v du. All right, that's where the formula comes from. It's just product rule backwards. So here du equals dx, and then v. All right, this also helps. If you have an integral like this, this will show up for sure. Know how to anti-derive this quickly. All right, it really helps if you can anti-derive quickly. And if we do that here, we're going to have 1/2 e to the 2x like this. Don't tack on plus c till the end. Actually, whatever, plus c, it's multiple choice. You're not going to lose out, but still, yeah, don't miss out. So I'm going to write it over here, or whatever. I'll just say, yeah, x e to the 2x dx equals, because you see, this is the integral of u dv. So now we're using the formula equals u times v, which is 1/2 x e to the 2x minus the integral of, we have the integral of v du. And the 1/2 I'm going to write in front. Doesn't matter. I could write it on the inside or the outside. And now this is 1/2 x e to the 2x minus, and here it is again. Okay, our k value is 2, so it's 1. So I already have a half there, but I'm going to have another half e to the 2x, and then I tack on my plus c. So this is 1/2 x e to the 2x minus, this is a product, so 1/4 e to the 2x plus c. Oh, they wrote it over 2. So 16, let me just look, is choice A. Yep, so that one. Oh, I like it. UV rays. I like all those like little oh yeah, you could do tabular, but they don't ask tabular really. They're not going to give you like x to the 3rd, e to the x. That was in that movie, Stand and Deliver. But yeah, they don't do that anymore. They kind of toned down on that. No, partial is simple. It is not going to be like one of those ax plus b ones. Yeah, they don't do that. And unless it's in college, they might. Yeah, washer is 2 functions. Disk is 1. Like you're going to have just 1 radius. That's a BC question we just did. Yeah. But integration by parts, that's the thing. BC is like not like crazy harder, except like unit 9 and unit 9.5 and 10. Because like the first part of unit 9, parametric, is easy if like you know the calculator and you know the formulas. Polar makes people depressed. And unit 10 is what gets people to change majors in college. Like that's just a hard major. Oh, here's an easy one. Hopefully easy. So you're like 1 over 3 minus 1 integral 1 to 3 1 over x dx. You're like 1/2 natural log 3 minus natural log 1. Natural log of 1 is 0. 1/2 ln 3 or ln 3 over 2. Choice D. All right. I hope. Yep, D. That's how fast you want to do these. Okay, know your formulas. Okay, you want to be able to do these quickly. All right, let's see. Logarithmic differentiation. I don't think they asked that anymore. Oh, there's a polar. Look out. See, they asked polar in 1988. The year I was born. All right, so this one, I would just say here, hang on a second. I got to mute for 1 second. And my kid is just getting up. Yeah. I'm not like crazy loud, but maybe I'm talking too loud. All right. So moving on, we have our function here. I know natural log is going to be involved, and I know it's going to be messy. Like my first instinct when I did this was like, oh, this is going to be E, and it is E. These questions are a little painful. This I would not worry too much about. This is more like just tedious, this question. So here, what I would do is, for one, I would just call this y equals, and I would say natural log y equals natural log of x squared plus 1 to the x. So we natural log both sides. The reason we do that is so we could bring this to the front. Okay, so we're using, oh wow, a tip. Thank you, at Leo Wang. Very generous of you. I appreciate the tip. Pleasant surprise. So here we're taking the derivative, and we're going to have 1 over y dy dx equals, and now this side we product rule. So it's going to be 1 times ln x squared plus 1 plus x times, and just know, useful formula, the derivative of natural log f of x is 1 over f of x, f prime of x. Okay, so it's going to be x squared plus 1, and then the derivative of x squared plus 1 is 2x. And then I have to multiply both sides by y. So I'll do that in the next step. Let me just clean this up first. So this is natural log of x squared plus 1 plus we have 2x squared over x squared plus 1 like this. Yeah, Leo Wang, I can't stress it enough. That was like super generous of you. Thank you. I'm still like getting used to like maybe hopefully someday being the AP Calc guy. I was inspired last year. Students were like, "Oh, you should start live streaming," and you know the guy Heimler for AP US. I know like he's like really popular and he does a great service. So like let me get started and see where this takes me, for sure. Because when I started YouTube, like I did enjoy it a lot, but in the beginning I was like I was learning and I was like new to teaching. Like I started doing YouTube before I was even a high school teacher. So I would say like teaching now for 10 years, I have like more confidence getting people ready for the AP test. Like I know, kind of what they're looking for and like how in depth you should know things and like when you don't have to worry as much. So to be at this point now where people are like throwing me tips and stuff, yeah, Heimler is like definitely one of the GOATs for sure. Also, if it's time to give shout outs, I would say I got to reach out to, what's his name? Turks Vids is like a really awesome dude. I'm a big fan of his channel. Like he's like the FRQ GOAT for sure. The guy's like really smart. He does Calc 3 as well. So, you know, he's a guy that I also look up to on YouTube, like for sure. Like the OGs of YouTube, like if I give like shout outs, I hope I don't miss anybody. Like, yeah, sorry if I miss you. If I don't mention, like I'm not trying to miss people right now. Patrick JMT. I'm not talking about new people. Although organic chem tutor, I think everybody knows who he is. Yay Math is like underrated. Like that guy has like the greatest heart on YouTube. Like he like dresses up like a chicken like in front of his classes, and like maybe someday I'd like want to do that and just get more like out there. But he's like a big inspiration like in terms of like from the YouTube side. So yeah, him, like Turks Vids, if you're out there, like, you know, like just, you know, from one YouTuber to another, like just a fan of the work you're doing. There's way more people. Oh yeah, Khan Academy. Like, you know, Khan is like definitely one of the OGs for sure. Who else in the math department is like, you know, there's way more. The list does go on. Sorry, like for anyone I don't. Oh yeah, what am I saying? Professor Leonard. This guy is like also like one of the, you know, biggest hearts on YouTube. Great guy. You know, if you want like a professor style type of instruction with long lectures, he's definitely your guy for when you go to college. And you know, not a YouTuber, but I always like to reference this site for calculus. Paul's Online Math Notes is one of my favorite resources. You know, definitely one of the best. Oh yeah, no, she used to be Math BFF. Now what is she? Nancy Pie? Nancy Pie is good. Yeah, Nancy Pie, she's brilliant. MIT graduate. Like I said, black pen, red pen. How could I? See, that's what I mean. This is tough. This is like me, black pen, red pen. Of course, 1000% is like. I'm subscribed to like basically all these people here. Like I love their channels. Like this is just math. If I talk about all the APs, then, you know, but you got to give them their shout outs. So here, y originally was this mess. X squared plus 1 to the x times, and then we have this stuff inside. All right, but this is one of those questions like, look, I wouldn't stress out about something like this. This is not a wreck your score question. Related rates, yes, I will scan for related rates. For something like this, I do have related rates later. Where's related rates? Oh, see, here's like Cavalieri's principle and whatnot. What time are we at? Oh, wow, we're going 4,500 views on this. Wow, just thrilled. This is, and we're at $21 of revenue. Wait, I forgot to say thank you to the second. I'm sorry if I, wait, where's the, let me scroll back. Oh, at Tegan, thank you so much for the $1. I greatly appreciate all of you, you know, being here and like just being a part of this. This is like very exciting to hit 4,500 views in an hour and 43 minutes. This is like just truly awesome. This is going to be probably my favorite day on YouTube for sure. All right, let's see. Arc length and total distance. Yeah, it's to the x power. Yeah, if they give you x to the x, like please don't say this. This is like LOL. No, don't do that. Okay, just exit all. All right. I appreciate that. That, you know, the comment. Aditya. I'm sorry if I'm butchering the. I'm trying. I'm really trying. It's effort, you know, because I'm also a dad. I have 2 like toddlers. So today I took them to the zoo, and we brushed the goat's hair. We played, you know, with the sheep, and then little man took a nap, and then I took them with my wife to the park to really burn them out so that they would sleep through this. It was like so important that they sleep. So yeah, I would love to put more time into YouTube, but it really is a balance. You know what I mean? Like, I don't want to be like too greedy where it takes over my whole life, but I really get a lot out of this. Like being here with everybody. It's, it's good for me. So one of the ideas, big idea, is when you're looking for theta, you want to think like set r equal to 0 is a big idea. Whoops, let's fix that. What is this? Oh, here we go. So set r equal to 0. Because what that tells you, like r is your, basically, I don't want to say distance because distance is always positive. But like r is like the space from the origin to the curve. And this is like the first part of unit 9, or is it the second part? Oh, the second part of unit 9. Like you have to know how to like plot polar points. So plot polar. Like if I had, I don't know, let's say the point, if I'm going like out 3 and over like pi over 3, I'm like, all right, 60 degrees is here. And like this is like 3 units out, so it's like 3 units this way. But if I had, let's say, -3 pi over 3, then I would start, I could go pi over 3 this way, but then I would go opposite. I would go straight through, so this would be like the point 3 pi over 3, but this would be the point -3 pi over 3. All right, so just being comfortable graphing in polar is like helpful. That's the only pre-calculus I would say that's like truly like important. If you don't have a calculator, if you have a calculator, that all changes. However, when you're trying to identify the area of the region enclosed, you want to think about, I think of like a windshield wiper motion, that as the radius extends, so like you see here, how here it's like we have at this first angle θ1, r is equal to 0. So r is equal to 0, and then r starts to increase. See, and as r starts to increase, like let's say like from here to here, like r is increasing. From here to here, r is getting even longer. And then from here, r is at its maximum. And then r starts to come back. But my thought process is I look for like, oh, set r equal to 0 between which two roots. So I'm thinking, all right, 4 cosine 3 theta equals 0. And this is hard to do without a calculator. But what helps me with this is I say, all right, well, I know cosine pi over 2 is 0. So that means I want the inside 3 theta to be equal to pi over 2. And then if you just divide both sides by 3 or multiply by a third, theta equals pi over 6. And that's this angle. That's pi over 6. So then this angle, it's symmetric, would be negative pi over 6. So that's why I'm looking for an answer that has negative pi over 6, pi over 6. So it's like most likely, one of these choices. And then from here, what you want to think of from negative pi over 6 to pi over 6, we want the area of the region enclosed by one loop, not the, this would be, if it was the whole thing, it would be like a 3-loop rose curve. Okay, so it's going to go from pi over 6 to negative pi over 6. And I know negative pi over 6 also works because if I plugged in negative pi over 6, see how you'd get like 4 cosine negative 3 pi over 6, and then you'd get negative pi over 2, and cosine of negative pi over 2 is 0. All right, so that's just like some of that trig stuff. It helps to know without a calculator. But I find that they really don't try to tag you on like trig stuff too hard. Like I wouldn't expect like 5 trig equations on the no calculator. Like that just seems kind of mean. Like there might be like one at most where like not knowing trig is gonna like hurt you. Like I said, they're not trying to test your knowledge of trig. They're trying to test your knowledge of calculus. So don't get too panicked on that. If you have a calculator, obviously this is easier. So, considering this, now that we know the angles, remember the formula. It's 1/2 from θ1 to θ2 of the equation squared. And if you square this, just square both sides, r squared equals, you're going to have 16 cosine squared 3 theta and d theta. All right, so now we scan the answer choices. Oh, hang on. Half of 16 is 8. So that helps. So we need an 8. And this has a 16, so that's too much. And it's cosine squared 3 theta. This one's not squared. So that's out. So choice E. Yay, choice E. All right. I went on a little bit of a tangent explaining like background stuff. Oh, this is just mean value theorem. This isn't that exciting. But yeah, this is just like set f prime of C equal to like f of 2 minus f of 0 over 2 minus 0. Okay, so this is like kind of like just algebra. Remember I said like it's mostly algebra, that test? But just know f prime is power rule 3x squared minus 4x. All right, so I'd have like, all right, why not? I'm already committed. Equals, you plug in 2, you get 8 minus 8 is 0. Minus, you plug in 0, you, oh wow, they made it equal 0. Well, that was, oh, not over 0, over 2 minus 0 is 2, because that would be undefined. So then you're just solving this. Oh, so factor out a C. And this factors nicely. You don't even have to do like, you know, trinomial factoring. It's just GCF. C equals 0 is no good because it's not between. You would want the other one where C equals 4/3. All right, so that one's better. So choice D on this one. Yep, choice D. All right. Oh, here we go. This is what people wanted to see, right? Like revolution and some wacky stuff from Unit 8. Let's see what time we're at. It is, what time is it? Wait, why is my, oh wow, 9:30. All right, we're doing all right. We're doing okay. This would be horrible though if I make everybody stay up way too late and then like people are sleep deprived and don't do well. So there is a point where sleeping is more beneficial. The test is early. So I will lead by example and set like a decent cutoff time. But we're closing in on 2 hours of streaming. So let's see. Wow, we got 200, almost 200 likes. Who's going to be the 200th like? And if we haven't gotten subscribers, anyone who hasn't subscribed yet, if you like what you see, consider joining. One of my goals, eventually I want to learn Calc 3 again. I used to know it. I was a math major. I took a lot of math classes, but I want to relearn Calc 3 and do it because like when my students graduate, that, you know, I teach in my actual high school, sometimes they say, oh, do you know Calc 3? Like, and they want me to make videos. But like my, you know, if you don't do math for like 10 plus years, you forget it. So I thought it'd be cool to like relearn Calc 3, linear algebra, differential equations, so that I can make content for students even after they leave me in high school. Because I don't want this to be the last math that I'm relevant for, you know. But I do plan on going back to and making videos on middle school math. So, yeah. All right. Oh, another sub. Thank you. Thank you. Thank you. All right. So let's see here. Parabola 4x squared. Okay. And the line x equals 1. So let's say that's here. And the x-axis. So that's, here we go. Let's see. Color it yellow. Highlight. That's the space here. All right, now that's the region. The base of the solid is the, oh, that's not going to look well. All right, let's see. It does not look well at all. So the base of the solid is this region. And the lines perpendicular to the x-axis are squares. Oh, those are like the nicest shape I guess they could give us. So you take the cross sections perpendicular to the x-axis, and they told you from like 0 to 1. So that was also polite. So you take those cross sections and you build them into squares. Okay, and the theme of Cavalier's principle is if you could describe the volume of one cross section, like, you know, like if I try to draw this thing, or like that's the region, all of these cross sections are turning into squares. So I can't imagine what this looks like. But whatever this thing is, we're finding the volume of it. All right, this is not easy to draw on one of these, you know, computer, you know, Wacom pads here. So that's solid. Like imagine these are popping up off the page. This is like an airplane view. We're finding the volume of this thing. So the y value tells you the dimensions of the square. So it's like 4x squared all around. And the thickness, like this is like an infinitesimal concept. that we're describing one cross section, and this is like infinitely thin. So the volume of one slice, this is like an infinitely small slice, is we would do 4x squared times 4x squared, that's 16x to the 4, and then dx. And then that's just the volume of one slice. We want the whole thing. So that's when we integrate from, we're starting at 0 and stopping at 1. So the volume would be 16x to the 5 over 5 from 0 to 1. And that would just be 16. Oh, here's a little trick. Leave the constant outside, and then you plug in for the x, like the top x and bottom x, and subtract on the inside. But this works for one term. Okay, if there's only one term, then this works. 16 over 5, choice D. All right, let's see. Oh yeah, ask your friend for about charge your calculators. This is all great. Thank you, Liam. That's great advice. Charge those calculators. Lucky if you're in California. Oh yeah, you get more time. Yeah, I would have started this earlier, but once again, I have 2 kids. So why did I start so late? I have 2 kids, and I got to make sure that they are asleep before I do this. Because, yeah, it's, what's it called? They're very little, and they're very needy. All right. Let's see. All right. When you know when to multiply the integral by... Oh, when do I know to multiply by pi? Would be revolution. You're multiplying by pi. So like if I had a disk like this, and this is like r, and this is like dx or dy, then the volume of one slice is like pi r squared dx or dy. And if it's, sorry, just got the hiccups. If we have 2 radii, if it's the washer method, then dv equals pi times the big radius squared minus the little radius squared dx or dy. So that's what revolution though, with spin. Unless they had said, hey, take those cross sections, and they said semicircle, and you're like, oh no, like then you have to use pi again. So it depends. Depends on the situation. All right, so we just answered this. Oh, this is just like properties of integrals. So let's see here. They told us f is a function, f prime exists for all x, and f is greater than 0 for all x. Which of the following is not necessarily true? All right. So for something like this, what you have is, let me just see here. F prime exists for all x means f is differentiable for all x, which means f is, let me get rid of this, continuous. Oh, just know for all, you could use this symbol. So f is continuous upside down a for all x. Okay. So yeah, let me just clean that up. That looks terrible. For all x. Sorry, this is like shifting a little bit because I had to like reconfigure the settings so that like this film's okay. So if f is continuous everywhere and f prime is positive everywhere, you want to think of like what's a potential graph of f. It's like, I don't know, it could be like something like this. Oh, at Matvey, thank you for the tip. I appreciate it. I really do appreciate the recognition here from everybody. Thank you so much. Very grateful. So for something like this, like the integral from -1 to 1 is greater than 0. This one is true. We want the one that's not true. So this one's out. All right, that's automatically going to be out here. This one, this is just a property of integrals. So this one is always true. So 26, like b is out because when you have like the integral of like c f of x dx from like a to b, this is like the same thing. constants attached by multiplication can be brought out. So that's one thing. Now, this one is the culprit. This one is not necessarily true. Now, what happens is people draw something and they're like, something like x squared plus 1. Make that neater. They're like x squared plus 1. And like, yeah, if you draw something even, the area from -1 to 1 is going to be equal to double the area from 0 to 1. Right? Because remember, the definite integral tells you the area under the curve. So, like, these things are equal. But draw something that's not symmetric. You know, draw maybe the e to the x curve. Like that, you could see like at -1 to 1, like this area is not the same as this big area. Okay, so this goes out the window. And this one, if you flip the limits, it negates the integral. And this one, if you break it up into two integrals from -1 to 0, 0's in the middle, you could go from -1 to 0 and add from 0 to 1. So that's why choice C is our solution. All right. Cool. Ooh, this is a nice question. This is a very nice question. This question's mean. I like 27. It's good. Let's just see. Yeah, if you didn't try 27 yet, try it out. This is unit 5. This one I need space. I'm gonna put it over here. Okay. See, 1988 coming in for the win. All right. So we're told here we have a graph of this point of inflection here, and maybe I'll just keep this in full screen because I haven't needed the calculator yet. We know we have a point of inflection at 1, -6, and this is a polynomial. So that means here that y double prime at x equals 1 is equal to 0. So we're going to make use of that fact, that because this is a polynomial, our point of inflection, our second derivative is going to be 0 there. And we have to find the value of b. So I would start by finding the second derivative, 3x squared plus 2ax plus b. And then y double prime would be 6x plus 2a. All right, and that means here, once again, when we plug in 1, we're going to get 0. So if I plug in x equals 1, I'm getting 6 times 1 plus 2 times a equals 0, which gives me, I'll just write it over here, 6 plus 2a equals 0, and algebra, a equals -3. Now, this is like, you know, LOL. If you circle this answer choice, they're asking you for b, not a. So we have to use this. We plug it back into the original. Okay, because they told us, let's see, y equals x to the third. And now we have minus 3x squared plus bx minus 4. The next thing they told us is that this is the point of inflection. Point of inflection, not infection. The point of inflection. This means it's on the curve. So that means we could just plug in -6 equals, plug in x equals 1. 1 minus 3 plus b minus 4. And this is going to give us -6 equals, this makes -2, and -2 minus 4 is -6 plus b. So b has to be 0. Choice B. All right. Yeah, this is like one of those like little algebra scavenger hunts. Am I going to be doing some FRQs? I could talk about some FRQs. Yeah. I mean, so I've been talking for 2 hours. That's good. You got choice B. Yep, it's going to be choice B at 0. This is, all right, let's see. This is just chain rule. Oh, here we go. Volume of revolution. That's what people wanted. Logistic growth. Yeah, I could do logistic growth. I don't know if there is a logistic growth question on this. Let me see. Yeah, I don't think so. But I could find one. Logistic growth is just, let me see. I got to think. Taylor series is coming up like fairly soon. Is it coming up soon? Where are you, Taylor series? Oh, there's related rates that people asked about. You know what I do have? To self-promote for a minute. I will link everybody to my Google Drive that I made for my Vintages math account. What I made a folder. Like if someone's like, oh, help me with Unit 7. Unit 7 and Unit 10 just came up in the chat. So if I do this, share, copy link, is like Unit 7. I made a practice test for just Unit 7. I mean, it is getting late for you to do like all this, but I have a video going over all the solutions. So I would look at this, and I have one also for, these are like one of my newer videos. So let me just copy the link. And this is my, for Unit 10. So I custom made my own practice test for each unit. And like I made free response questions that were like basically just that unit. And I have like, those are like 5 videos that I made. So if you want to watch that, look at those questions. If there's any you can't do, watch the video. And I go through it. Because I could pull one of those up right now, but I think it's better to have the one that like I planned it, I explained it carefully, and I edited it very carefully. Just in case I don't get to stuff you specifically want. Yeah. So here, chain rule for calc A, B, and B, C people. So here we're taking the derivative of natural log, and let's see, we're going 1 over cosine pi over x, and then the derivative of cosine is minus sine pi over x. And then the derivative of pi over x. Oh, Christian, thank you so much for the tip. This is very exciting. I've never really had a live stream like this where I'm like getting tips and stuff. This is like really cool knowing it got to this point. So thank you like for validating this like whole process. And you know, good luck tomorrow. Good luck to everybody. And once again, thank you for making this live stream possible. You know, if I was just up here talking to 0 people, I mean, I guess I would just be making a video. But live streams are like really cool. We had 6,000 people visit so far. Wow. That is like really sick. Because for me to make a video and it to get to 10,000 views, like it usually takes me like at least like a solid year for a video to hit 10,000 views. And we're already at 6,000. Like that's, how different is AP Calc from taking it in college? Very different. Because in college, I went to a college where you didn't get to use a calculator for calculus. So a lot of the questions they ask you in AP Calculus, they just don't ask you in university. Like you're just like, kind of, how to say it best? Yeah, you're just like doing more math by hand, which I think is like in some ways better. That's why I like this practice test. It's like no calculator stuff. Oh yeah, so let's see, times minus pi over x squared. So negative negative goes positive. Sine over cosine is tangent. So this is tangent of pi over x. Everything's positive now, times pi over x squared. Choice E? Let's see. Chain rule. Yep, choice E. How nice. 100, I would say so. Yeah, AP Calc, if you get a 5 on AP Calc, like BC, you're definitely ready for Calc 3. Is useless. Oh no. Kidmail, you came here to an AP Calc review to say AP Calc. Well, that's more of a philosophical question. Like the theme today is getting people ready for the test. But if you want to get philosophical, like what's the point of doing any schoolwork? I don't have like the mental energy. I'll just let you win that battle. Like what's the point? I guess it's like how you want to be spending your time. The prize, I guess, is that you transfer in credits. If you're going to be like a STEM major or something, you don't even have to be a STEM major to take AP Calc. But if you are going to be a STEM major, then it gives you like a little bit of an edge that you took something difficult as a high schooler. you definitely deserve, if you get a 5, you get to brag for life. You know, that's bragging rights for a long time. So cool. But just know, like, if you don't do well, because some people are really stressed out about their scores. Like, tomorrow's going to come and go regardless of how you do. You know, that's just how life goes. I've gotten, like, every grade you could get on a math test. You know, like my Calc 5 final, I got, like, 100. And I was like, yay, I'm so smart. And then I've turned in blank math tests and, like, dropped the class. Like, I was just not in the mental state to, like, make it through a really hard math class. Like that particular class. It was like advanced linear algebra, something insane. The professor was like super smart. He's like a Princeton professor, Princeton graduate who was like from Romania and like knew how to do math when he was like 4 years old. He was like just, math Olympiad gold medalist, like crazy smart. So like I didn't do well on his test, but like, you could stop. I guess Calc 5 would be like partial differential equations. Like you need Calculus 3 to do it. So like don't define yourself on like one day for 3 hours, because like let's say someone gets a 5. I'm gonna tell the story. These are actual characters, and if they actually, you know what, I'll make up fake names so that I don't get hit with like a defamation suit. So I'm gonna call one guy Hank. Hank took AP Calc BC, got a 5. Took AP Chem and he got a 5. Took AP, one other one, like AP something, got a 5. So he was he lived on my floor, and he was an engineer, and he had like Calc 3, and then like engineering, blah 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 blah, whatever. So that's Hank. Everyone's like, wow, and he was like, I'm so smart, I got 5s on everything. And then there was a fake name, Randy, who basically didn't take any AP classes. High school average was like, I don't know, like 91, like nothing, like not like he wasn't like top 5% of his school or anything. But this guy failed out, and this guy was a 3.95 in electrical engineering. It was basically like almost valedictorian. So just know, like, tomorrow is a big deal. Like, it could save you a lot of money, but it's not the end all be all. So once again, if you don't do well, don't stress yourself out. You could just learn something about yourself. Be honest. Like, how hard did you work? How hard did you work, like, to get to this level? What else could you have done different? Because it's all about, like, finding new ways of revising your work ethic to just keep pushing you to that next level. All right, so I always like to tell the story of those two because, I think, once again, the AP is like, it's really a big deal because if you're a high schooler, it's like the biggest test you ever took. But like 4 years from now, you'll be graduating college maybe. It took me 5 years because I didn't have things figured out. But, you might be graduating college and you'll be looking for jobs. And they might have a conversation with you about AP Calc BC, but that's not going to really decide what job you get, So just do your best and try not to worry too much. So here's chapter 8 coming up. So another sip of water. All right, let's see. My green screen is starting to give out here. Wait a second. I got to fix my green screen video capture device. No one was complaining about that. You're all so nice. All right, let's see. Behind the scenes, let's fix that chroma key. Oh, there goes my head. All right, ready? You're going to find out what's really going on behind me. Okay, so I got to just redo the chroma key. I think I probably moved too much or something, or the lighting out there changed. All right, ready? There goes my background. Goodbye. Green screen. That's the fun part of YouTube, like having to learn all this extra stuff. It's like really like so many moving parts to making this run smoothly. I guess it's like somewhat unprofessional for me to do that, like, but like it should theoretically all be working, but whatever. Okay, so moving on here. So this one, we've got x squared plus 1. we got the line x equals 0 and x equals 5, like way out here. And it's bounded by this, the graph. Wait. Let's think about this. Oh, y equals 5. Nobody yelled at me. Y equals 5. Okay, that's up here. All right, let's make that neater now. Sorry, I'm starting to be like fried a little bit. It's like I've been going for a while, over 2 hours. Okay, so that's this space. But you see it was unbounded, so I was like, I knew something was up. And we're spinning this around the y-axis. Oh, all right, so if we're spinning this around the y-axis, notice that there's no gap. Like that's our axis, and the region is like on the y-axis. So this is a disk. Okay, so I spin this around. Like this, and this is going to be dy. So this I actually want to solve for x. You could use the shell method, but they don't do shell method anymore. So yeah, we're just going to do like current stuff. Actually, I would even be curious if shell method no, shell method should theoretically work here, but whatever. This isn't shell method. So you need this, like, see how this is the point x, y? We need that horizontal space. We need it to be in terms of x equals. So I would solve this for x. I would have y minus 1 equals x squared, which would tell me x equals square root of y minus 1. And since we're in quadrant 1, I'm going with the plus, not the minus square root. Otherwise, I'd be in quadrant 2. And let's think here. Okay, so the volume of one slice is pi times the radius squared, in this case dy, and the radius is equal to x, and x equals this. So I'd have dv equals pi times, I would have radical y minus 1, and this is being squared dy, like this. Now, one thing to be mindful of, you see how the y-intercept of this is at like the point 0, 1. So my limits of integration are going to be from y equals 1 to y equals 5. So I'm integrating from 1 to 5, like this. So the volume equals, I'm going to have pi times the integral 1 to 5, and I got y minus 1 dy because the radical disappears when we square this. And this is going to be pi times 1/2 y squared minus y from 1 to 5. And now we plug in. So pi times half of 25 minus 5. All right, these numbers are a little gross. Minus, let's hope this works out nice. Plug in 1, you got a half minus 1. So here, strategically, like if I didn't have a calculator, although I hope they don't give you something this bad. I think they were like less nice in the past. They've kind of lightened up. This is 25 over 2 minus 5 minus a half plus 1. I would combine these two. So you see we have pi times 25 over 2 minus 1 over 2 is 24 over 2. And minus 5 plus 1 is minus 4. So this is going to give us pi times 12 minus 4, which is 8 pi, which is choice B. 29 should be B. So volume of revolution, fun stuff. This is 2 hours long, and 2 hours and 18 minutes so far by the time I noticed this comment. Yeah. All right. Let's see. Yeah, I'm burning out. Oh, arc length. Someone asked for arc length. All right. Oh, just know the formula. Integral a to b. I'm not going to prove the formula because I'm getting tired. So I got to like move a little faster. But welcome to anyone who just joined. If you are not subscribed, I'm not going to say, I would say I would appreciate a sub if you are open to subscribing, if it's not much effort to you. I got that little reminder at the top. But today I think is going to set records for me on YouTube. Wow, almost closing in on like 6,800 views on this. That is really cool. And we got 650 people here right now. And we made $30. Thank you once again to everyone who contributed big time. But you all contributed by being here. Like it's YouTube is gonna probably reward me in some way for having everybody here. So thank you so much. F prime of x equals, the derivative is 3x squared. So you just plug in from 0 to 2. It's like integral 0 to 2 radical 1 plus. And now we square the derivative. So if you square this, 3 times 3 is 9. X squared squared is x to the 4. Dx, no pi. That's a distraction. Where are you, answer? Choice E, looks like. 33 is E. It is. Oh, smash. I guess that means we smashed the subscribe button. Very cool. Thank you so much. Yeah, I'm curious. I want to peek at the numbers. Because the day before the AP test is always my best day of the year. But I want to see. How many subscribers did we get? Oh, wow. All right. Yeah, today's like a record for me. How many subscribers? Oh, yeah, it's going pretty wild. Wow, 5,700 views in 1 hour. Yeah, today is like absolutely massive. Wow, over 200 subscribers in 1 day. That's a record for me. I'm like blown away here. This is like really cool. I've never broke 200 subscribers in 1 day. I never even broke 100 subscribers in 1 day. And the numbers are just like rolling here. Everyone pressing that sub button. Thank you so much. And more tips. Oh, wow. Thank you so much. Joseph, good luck tomorrow. All right. I'm really rooting for you. You know, convergence test. All right. So at Liba, I posted something earlier. I have a video on just Unit 10 stuff. Let me find the video. I mean, I could pull up some random stuff here. Let's see. Let me try to like zoom ahead a little bit. Oh, like here we go. Here's like radius of, interval of convergence. That's like ratio test stuff. Where's the other? Oh, here we go. This one. All right, I could go a little out of order. Why not? So question 44. This one, which of the following series converge? Oh, this one is hilarious. All right. This one is sneaky. Sneaky. Okay, but this one converges by the alternating series test. So the way you would use the alternating series test here is what you want to focus on is I call that like the B sub n. And in this case here, we have the sequence of terms is decreasing. Okay, and the limit as n goes to infinity of 1 over 2n plus 1 is equal to 0. So this would be like for the free response, you would write this. So therefore, the series converges. Okay, and this is by the alternating series test. You don't have to cite the test. Like I tell my students to because it's like nicer. Oh yeah, and also n equals 1 to infinity. Okay, but I just look at this. I'm like, oh, it's alternating. Oh, this is decreasing and it goes to 0. So converges. Like this is more for FRQ. You don't need to write this for multiple choice questions. Okay, this is just like me being more formal here. So this converges. So that means this is out and this is out. Now this one, even if this wasn't here, oh, and thank you so much for the subs. I'm like watching it live. It's like I can't help but look and be like, oh wow, more subscribers, more subscribers. So thank you. So here, even if like 1 over, like this is harmonic. Okay, and this is geometric. So let me get this out of the way. Sorry if you're still writing that. You can always rewind and pause. All right, so let me change colors here. And this, like R would be equal to like, this is not a geometric series, but it's like part harmonic, part geometric. And since 3/2 is greater than 1, like I'm already seeing this diverges. Okay, because like even though like you're like, oh, but I'm dividing by n. But yeah, like what I'm thinking of is like the leading big idea. Actually, let me write that over on the side. Big idea is that the leading terms make all the difference. So here it would be like 3 to the n, or I even say it like this, 1.5 to the n if I divide those, versus n. And like this, like the limit as n goes to infinity goes to infinity. So by like the nth term test, see how like this diverges. It doesn't even go like for the nth term test, the nth term has to go to 0. Like, I'm sorry, if the nth term is not 0, like this, see how it's going to infinity? It's not going to 0. This diverges automatically. So just take the limit at infinity. This one is evil, okay? This one is so evil. Because I know, like, this is like a high-level trap here. Okay, so this is like high-level trap. I was going to make a video on, like, just this question. This high-level trap. Because this is the thought process. And be honest, this, if you pick this answer choice, I'm sorry. Like, if you pick this, like, sorry, this is wrong. All right. And I'll tell you what your thinking was. I'm able to read your mind if you pick that. So this is the thought process. You're like, I know P series so well. I am the P series master. And you're like, all right, so I know P series. And you're like, this diverges. And you're like, but this converges. Like even like 1.01, like this converges. So you're looking at that and you're like, all right, surely like natural log n has to be strong enough like to bump like the series 1 over n into convergence, right? Like that's the most common incorrect thinking on this question, but it's wrong. And the reason it's wrong is if you want to show why this diverges, you would use the integral test. If you look at this integral, I could show this integral diverges. I'm not going to show u sub right now, but I promise you the antiderivative. Oh, and also, I'm about to write bad notation. Okay, but it's multiple choice. So LOL. All right, doesn't matter. All right, you could have bad notation and multiple choice. So I'm not gonna write limit as b goes. So I'm not doing all that stuff here. Every time I have to write that, I'm like a little bit in pain. So I'm not doing that here. So this is actually natural log of natural log x. That's the antiderivative. And you could check me on this. Take the derivative, you'll get this from 2 to infinity, which is natural log infinity minus natural log 2. Natural log infinity goes to infinity. Natural log infinity goes to infinity. So this whole thing goes to infinity. It diverges, which means the corresponding series diverges. So that's why it's just 1 only. All right, so that's a few different tests. Oh, wait, well, no, what's going on here? I hear like, we got to keep it real in the chat. I should have established community guidelines. Keep it real. I should have like maybe designated a moderator. I mean, I hope it's just playful. But yeah, let's keep it real here. All right. So let's move on. Geometric series was earlier. All right, let's see, what do we leave out? Give a shout out to Dr. Dan's class. Sure. Shout out to Dr. Dan's class. Anyone here? All right. Shout out to, oh wow, 7,300 views we broke. This is pretty amazing. All right. Oh, area between polar curves. I think we mentioned, there might be one later. I'm not sure, but oh, Lagrange error rewind. I did a whole FRQ on Lagrange error at Aiden. I forget which time it was, but if you rewind back, I did Lagrange earlier, and it was quite painful. 37. Ooh, street light. All right, let's do it. Where are we at on time? Oh, wow, 2.5 hours I'm going. All right, yeah, I probably have like another 20 minutes in me, and I'm going to bow out because I am tired. Although, like, this is like really cool to be a part of this. Yeah, subs are just flying up. Thank you for subscribing, everybody. I do appreciate this so much. My goal is to just, help as many people as I can get the best scores they could get. That's why I'm doing this. Just make, because math has a reputation of like ruining people. Like it's like there's math phobia, and you got to just like, keep at it, keep moving. All right. So let's see. We have a person is walking away from a streetlight. So here's the person. So they're walking. Okay. Now let's see. They're 2 meters tall. The light is 8 meters above ground. Okay, so X, we're going to define variables, X and Y. This is like their distance to the light. All right, which will tell you how fast they're going. Y is like the light is hitting them. So there's the light, and it's like hitting them. And then shadow. So, oh no, I'm a bad artist. Whatever, like this is their shadow. Forgive me. I can't draw. Okay. So now we have this stuff. If the person is walking at a constant rate, so that's dx dt, and the person's shadow is lengthening at this rate. Oh, here we go. So that's dy dt is 4/9 meters per second. What is the rate in meters per second that they're walking? So what's dx dt? All right. Oh, this is a fun one. This is similar triangles. So this is 8, like this is the big triangle, 8 and then x plus y. And I know we all, like most of us learned geometry like during COVID and it was remote. So remote learning like wasn't the most effective. So similar triangles is like a big idea from geometry. But you set up a ratio, 8 over x plus y, or a proportion. We're comparing two ratios. Like this and this is true. Like this over this equals this over this. And if I cross multiply, I'm going to have 8y equals 2x plus 2y. And we've got 6y equals 2x. We're solving for dx dt. So that means I would want to get x by itself. I don't have to just get x by itself, but it makes it nicer. So now x equals 3y. And what we're going to do here is take the derivative with respect to time. And we got dx dt equals 3 dy dt. So dx dt equals 3 times 4/9, which is 4/3, which is choice D. All right, cool. Don't worry, if you don't pass tomorrow, you'll still be you. All right, let's see. That was 37. Oh, this one should be easy. 0. So this is for everybody. More for BC people, but like if I had to explain, like, x to the k versus, how would I say it? Let me think of it like this. How about like x squared? Even like, no, I'm sorry, x to the 100 versus 2 to the x. Versus like x factorial versus x to the x. This is like strong. This is stronger. This is like Thanos. And this is like Thanos with infinity stones. Okay. Power functions are strong, but exponential functions are stronger. So you see you have like a power on top and an exponential on bottom. So an exponential function in the denominator versus a power on top, the exponential, like the denominator is growing at a faster rate, so the limit goes to 0. Like that's just, you could just think about that, like if you know the concept of limits. Or you could do L'Hopital's rule, k times, but I don't think that's necessary. All right. Hang on, so take a look here. Oh, here we go. How about an interval of convergence? So for this one, you could just do by brute force. Let me make space. This is a fresh page question. Yeah, I could just screenshot it and drag it up. All right. So here, let's see where we are. And we're almost done too. I'm getting towards the end. So if you want to do it the long way, you could just ratio test. Remember, you're taking the limit as n goes to infinity of a sub n plus 1 over a sub n. I mean, I might as well show this. And you want this to be less than 1. So here, like a sub n is this. This part could go on in your head. If you're really good at the algebra, you could do this in your head. Okay, so I would take the limit as n goes to infinity of a sub n plus 1 divided by a sub n. But when I divide by a fraction, that's going to turn into this. And now when I simplify this, I look at this, and another thought, I'm like n plus 1 versus n. You know, like law of exponents, when you divide like a to the b over a to the c, it's a to the b minus c. Like if you subtract those, you're going to be left with like this is gone completely and we're left with the 1. Or I see like, oh, this wins by 1. So like, once again, that algebra, you got to be good at algebra for this stuff. So now this becomes the limit as n goes to infinity of, we're going to have absolute value of x. That has to stay in the absolute value because x is a variable. Like that x could be anything right now. N is going to positive infinity. So if n is positive, n over n plus 1 is positive. So this could just exit. And now unit 1 of the AP test, like know that when you have matching degrees, the limit as n goes to infinity of this expression is just the ratio of the coefficients. So that's going to just work out to absolute value x. And that piece, we're going to set less than 1. Now, absolute value of x is less than 1 tells us our interior interval is this. Okay, our radius of convergence is 1. The center of a series is the x value that makes everything 0. So we have a center at 0. We have a radius of convergence of 1. We know that by this step. However, if you're not careful, you might choose this answer choice and it would be devastating. All right, we know it's not all real numbers because we have to be between -1 and 1. But now you would test. Now, I'm only showing this because like this is like FRQ friendly. All right, because honestly, I would just look at this question and I would just plug x equals 1. Like me personally, like this is all I'm doing. Okay, because it's multiple choice. And if I plug in x equals -1, I'm not even writing n equals 1 to infinity because time is money on the AP test. And I'd have -1 to the n over n. And if you know your series, this is alternating harmonic. And that converges. Okay, otherwise, you got to use the alternating series test to show convergence. So we converge at -1, which means now this result here allows us to put an equal to. So this is out, and this is out. But now the million-dollar question is, do we have convergence at x equals 1? So at x equals 1, let's see, at x equals 1, we have 1 over n, and that's harmonic. I wouldn't wage all my money on this. So at x equals 1, we diverge. So we're not going to put it equal to. So only -1 gets included, which is why it's choice C and not A. All right, but I would put my a lot of money on this, that they're going to make use of you knowing, like, you know, when you get sigma 1 over n, like, oh, harmonic series diverges. Like, if you just know that, then great. So it's going to be choice C. But once again, I could answer this question in like under a minute because all I'm doing is this. All right, like that's how I know like that this is going to work out. All right. So that's that. Derivative of the inverse. U sub. I don't know. Let me see. What time is it? I think. I don't know if I just do a speed run. What time are we at? 10:19. Yeah, I think I'm just gonna speed run through the rest. How much is left? Oh, I don't know if I want to do this one. Do we want to see an optimization? Oh, at Pana, free response 6. I'll be honest, like, I'll just give a shout out to Turk's vids. At this point, I'm like, yeah, I'm not gonna do any FRQs from this point on. We've been going for like 2 hours and 40 minutes. I'm like starting to burn out. All right, so hyperspeed. All right, so here we go. So just did this one. So this one is differential equation. So dy at hyperspeed, dy over y equals secant squared x dx. Integrate both sides, and you get natural log absolute value y equals tan x plus c. Plug in 0, plug in 5 to get c, and you got natural log 5 equals c. Plug it back in. Natural log of just y equals tan x plus ln 5. Raise both sides as powers of e, and you got y equals e to the tan x. You can write that as times e to the ln 5, law of exponents from algebra 1. This cancels to make 5e to the tan x, choice C. All right, sorry, this may be less educational, but I'm getting tired and I want to cover everything before I go. All right, so here, G is F inverse. So if G is equal to F inverse, then G prime of X is equal to 1 over F prime F inverse of X. So they told us G of -2, which is equal to F inverse of -2, and that's equal to 5. So we're looking for 1 over F prime of 5. And F prime of 5 is -½. So this is 1 over -½, which is -2, choice E. Sorry, this is the fast version. Ugh. All right, these are my least favorite questions in the world because you have to know formulas. Just know like the formula for integral from a to b of f of x dx. I'll use the right Riemann sum. All right, from, let's see, n equals, they're using n. Oh no, they're gonna use k here, I'm sorry. K to, so k equals 1 to n of f of a plus k delta x times delta x. And you gotta know delta x is b minus a over n. All right, so here, it looks like b minus a in all these cases, like a and b, they're all 1 away from each other. So delta x is going to be 1 over n. So just starting to clean this up a bit. K over n. All right, let's see. Oh, all right, so this is what gives it away. This is like delta x. And this is determined by f. Like f determines this. Yeah, this is like one of those annoying questions that it's like not worth stressing over. This is one question at most. Okay, so for this, I'm looking at this thing, square root has to be involved. So like goodbye, and it's like one of these, but even this would be like x radical x. I'd have stuff on the outside of those. This would be like x to the 3/2. So like, I'm not liking this one. I'm like most likely just gonna say, chop this. So it's like one of those. This is easier. So like I wanna try this first. And I think it's gonna be this one anyway. Yeah, it's gonna be this one. Just thinking about it in my head. See, I can't even super speed this one. This one I gotta think. All right, so here that would be an a value of 0 and a b value of 1. And our f of x is square root x. So you see how if we plug into the series here, I'm going to leave this part out, and I'm just going to try to build this. This is sigma k equals 1 to n of f of a is 0. So I have like 0 plus k delta x. So I have k over n like this times delta x, which is 1 over n. So this, if I start plugging in, see how f of, I'll make that neater, k over n. So this, I plug in k equals 1. And if I have f of 1 over n, I'm going to have square root of 1 over n. Plus, now I plug in 2, and I'm going to have, this I could even replace with this step. It's like f of k over n would be square root of k over n, like this. So now that even, like, see how like that would feed it better. It would make more sense then. Plus square root of 2 over n plus dot dot dot. So this goes on, and then we're multiplying by 1 over n in front or in the back, which does match this. So B is it. Yeah, those are annoying. I don't like those. Yeah, Andrew, I think they might throw like 1 on. That's technically, I have to look at the curriculum. I think most teachers don't teach it because it's like, it just kind of stinks. I show it, but I'm like, all right, I have to show this, but I hate it. So like, you know, forgive me. Whoops, there went the whole thing. Let me actually just look at the topics. So that's unit 6. Unit 6. Riemann sums, summation notation. Yeah, no, it's there. I think it's like this topic. It might be this topic. I'm not 100% sure. Let me see. Yeah, because it's like the concept of what an integral is. Which, all right, this one, u sub, u, whoops, make it neater. U equals 5 minus x. Du is minus dx. Minus du equals dx. Find new limits. The new limits are going to be u equals, you plug in the old limits. So this is the if. So x equals 4. 5 minus 4 is 1. Plug in 1. 5 minus 1 is 4. So our new integral, if we do the u sub on this, is going to give us on the left, we're going to have from 4 to 1. We're going to have, I'm sorry, let me kind of like backtrack a little bit. This was, I went a little too fast. 5 minus 4 is 1. Yeah, this part is fine. I mean, we're adjusting this. What is the value of this? This is the one we're adjusting. We're using this to evaluate this. So now we have integral 4 to 1. F of u dx is minus du. And if we flip the limits, it's 1 to 4 f of u du. And that matches what we started with, which equals 6. So A. All right. This one. All right. Yeah, I'm running. Oh, wait, I only have 2 more questions. Good. And I'm done. All right. So let's really just power through this. The last one is the worst. The last one's the worst because if you don't have a calculator, it's like awful. But they wouldn't make it that bad anymore. That would be really cruel. So this one is a differential equation topic. Bacteria increase at a rate proportional to the number present. So that's knowing this. And then from here, you are just allowed to say this. Okay, this is like the exponential model. Otherwise, you got to do a lot of crazy stuff. The number of bacteria doubles in 3 hours. Okay, so P of 0 is just equal to C. So in 3 hours, it would double to 2C. So P of 3, I would say, is equal to CE to the 3 times K. And that's going to be equal to, make that neater, 2 times C. So C over C cancels. And now we got e to the 3K equals, oh, wait a minute. Give me, oh yeah, 3K equals 2. All right, we're good. So natural log both sides. You natural log both sides, 3K equals natural log 2. So k equals ln 2 over 3. And then you plug it back in. Okay, so we get here. And then how many hours for the bacteria to triple? So set p equal to 3c. C over C cancels, and then algebra. All right, so you got natural log 3 equals ln 2 over 3 times t, and then just multiply both sides by the reciprocal. See you later to this. 3 ln 3 over ln 2, where are you? A? Is that one A? Let's check. It is. Cool. All right. And now, for the grand finale, last one I'm doing. Oof. All right, so this is an ellipse. They don't ask these really anymore, but it's optimization. That one annoying question everyone wanted. If you set x equal to 0, you get 9y squared equals 36. Y equals plus or minus 2. So this like helps you sketch it. All right, so that gets you here. So plus 2 and minus 2. But if you set y equal to 0, that would give you 4x squared equals 36. Or x squared equals 9. X equals plus or minus 3, which gives you the x-intercepts. All right, so this is the ellipse. Once again, you're not going to have to know this, but like how to sketch one of these. They're more likely to give you like a parabola instead of an ellipse if they were going to do something like this. So the rectangle would look something like this, the largest area. So the area of this, just think, this is the point xy. You go over x, up y. So you see the dimensions, it would be like from here to here is x. See, like from here to here is x. So from here all the way across is 2x. So the formula, and I'm going to use a calculator for this because I really don't feel like doing the algebra. It's like I've done the algebra, it's like insanely messy. And the height would be 2y. Okay, so it's like length times width, which becomes 2x times 2y. So like length times width. But y, I'm going to solve for y. We take this equation. We want to turn this into one variable. So if I solve for y, I would have 9y squared equals 36 minus 4x squared. Divide everything by 9. And you got y squared equals 4 minus 4/9 x squared. And take the square root. And we'll go with the positive root because it'll make life easier. And we get here. So the area is going to be equal to 4 times x times y, but y is equal to this whole mess. Okay, so that gets us here. But now we want to find the area of the largest rectangle. So this is a function of x now, so I could say what's the derivative here of this function of x? And that's why I'm going to use I've done the algebra for this once again, but it's like insanely messy. And I'm like running out of steam. Oh wait, I gotta shrink this, that's why. Here we are. All right, so I'm gonna go back to function. So this is our function. We had, let's see, it was 4x square root of 4 minus 4/9. If you want to learn how to write a fraction, alpha y equals enter 4/9 x squared. This will just keep you neat. Okay, and we have to take the derivative of this. So ready? Magic. Math 8. Derivative with respect to x of alpha trace y1. Take the derivative of y1. All right, alpha trace is a nice trick. Now what I do is I turn this first graph off. And I'm going to go from like, be mindful, the domain, x is going from like 0 to 3, like -3 to 3. But since I took the positive stuff, like I'm in quadrant 1, I'm just going to look from like 0 to 3. And there it is. And notice this is a graph of our derivative. It's a sign change from positive to negative. Okay, so here's the concept. And then I'll come back to this. So since this is a graph of, like, once again, this is A prime, and this is the only sign change. Okay, this is like the only critical point. I'll abbreviate. The only critical point. So since it's the only critical point and it's a sign change from plus to minus, not only is it a local max, I'll leave that out, it's the absolute max. All right, because think about it. If your derivative is positive, your function is going up, and then it's negative, you're going down. Now that's the only time your derivative changes signs. Like you have one critical point. Not only is it a local max, it's the absolute max. So that's why conceptually this is telling us the absolute max. So I just need to know the root. Second trace 0. All right, enter before, enter after, enter a third time. And we get this. Now I'm going to save that. Save that answer. I'm going to store that as like the letter A for answer. Okay, so we just press second answer, enter, and then store as A. And now when I go back to this, I'm going to put my table, it's usually on auto, like this, but I'm going to switch it to ask. Because I want to know what is the area at that value we just found. I don't know what I just pressed. Give me a second. All right, here we are. Oh, alpha. All right, alpha A. Oh, hang on. I have the first graph. Now I want the first graph back on. So I want to know what is the area. So this was my area function. So now I look, and my area is 12. Okay, so that is the max area. Choice B. All right. Looking at the chat, I am going to say here, good luck to you all. All right, I'm going to end the stream here because I'm officially burned out. I did almost 3 hours here. Oh, we got a donation. Thank you, Janet, for the donation of $20. So awesome. It was quite the event. All right. Oh, Riker at 99 cents. Thank you. Thank you. Anyone? Yeah. Look, donations and people who joined. Thank you so much. We broke 8,664 views on this. All right. And there's 400 of you here right now. Thank you so much. This is like really like a dream come true to hit this level on YouTube. And spread the word, because next year I'm going to do the same thing again. And I'm going to try to get this even, you know, just keep pushing it to the next level. But I appreciate you all for being a part of, you know, this like review and helping me push this channel to the next level. Like you all really make it possible. So thank you. Good luck. And remember, 24 hours, that test is over, regardless of how you do. Just do your best. You're going to learn from this no matter how it goes. So take care.